Hello everyone and welcome back to another episode of the WeAreDevelopers Live Days. My name is Benedict. I'm Community Manager here at WeAreDevelopers and I'm glad that you all made it today. So today is all about Vue.js, but before we start with the topic, just some quick informations. Maybe if you haven't heard yet, our World Congress is back as an in-person event taking place in Berlin in July. And maybe let's have a look what Håkon Wyon Lee has to say about it.
To reach so many people face to face in one place is quite unique.
So if that 10-second sneak peek wasn't enough for you, go to worldcongress.dev to gain further information and to claim your tickets. And furthermore, if you are interested in diving into the virtual reality world, I have also some good news for you. Together with our partner Deloitte, we are raffling out a MetaQuest 2 VR headset. Just scroll down on the live page and join the raffle. And during the talks, as we go on, feel free to interact in the chat to your right. If you have some questions, please submit them with the Ask button, but keep in mind to be nice to each other and respect each other as we have a code of conduct. Here's a short video about it. And now, right back to Vue.js. And we start with the first speaker of the day, who is a colleague of mine, actually. He's DevRel lead here at WeAreDevelopers. And while he's not generating images with AI or brewing his own coffee for our Coffee with Developers event, he's taking flight lessons to gain his own pilot license. Joining us from Luxembourg, welcome, Marc.
Hello, welcome, Benedict.
Hello,
thank
Marc.
you for the nice introduction.
Yes,
I heard you just a second ago you talked about virtual reality. I got my own little virtual reality headset that I got just last week, and I think it's the same one that we are raffling away. So this is pretty cool.
It actually is. So you can assure us that it's a really nice thing to have, I think.
I haven't tried it that much yet, but the little that I tried, especially super hot in VR, is very cool. So I can just recommend it.
So the people should miss the chance to win one.
Yes.
All right, Marc, first things first, happy belated birthday. Since
Thank
I
you.
forgot to write you yesterday. And
thanks a lot, Benny.
And second, also relevant for our viewers, maybe you want to just tell us what we're going to learn from you today in one or two quick sentences.
Yes, of course. So we are going to take a look at the Vue 3 reactivity engine. So often you just change a value somewhere in Vue.js and it updates everywhere. But how does that exactly work? We often don't know. And I want to shed a little bit light on it. Take a little look behind the curtains of Vue.js, how this particular thing works.
Awesome. So a little bit behind the scenes with Marc today. You got my full attention, Marc, and also that from the audience, I think so. So I would say, without further ado, stage is all yours.
Thank you. All right. Cool. We have the... Okay. So, yeah, we are going to build Vue 3 on stage. As I just said, we are going to take a little bit look behind the scenes. First, we are going to look a little bit at the theory of it all, how it works, and then we are actually going to build from scratch. We're going to code step by step this reactivity engine. A little bit about myself. As Benny already said, I'm in flight school getting my pilot's license. That's me on the left with after my first flight. That's for anyone that's interested in planes. This is the Piper PA-28. That's my training aircraft that I do all my exercises on. Well, yeah, I'm DevRel lead here at WeAreDevelopers, where I do a lot of different things. All of them are exciting. I work a lot with the community, but lately I've been working on a very, very, very cool in-person event for developers. I can't tell too much about it just yet, but if you hang on 1 or 2 more weeks, we have something very cool to announce, and I think you will all love this. So keep an eye out for that. I'm also helping with the Congress a lot. I take a look at the CFPs. I help structure the agenda, and that's what I do here. Yeah, I'm based in Luxembourg, and I love working with Vue and Nuxt. I'm a Vue developer for a few years in a German company, but now I'm here at WeAreDevelopers as DevRel lead. Yeah, I'm home barista. It sounds fancier than it is, but I do like to educate myself about my coffee at home, especially because I live in the middle of nowhere. I live in the Luxembourg countryside, so I have to brew my own coffee because there's not much choice on coffee shops here, and brewing my own coffee makes it better. I think I with more and more practice, I get very close to something where I can say my coffee is better than 95% of what I get at coffee shops, restaurants, you name it. So that's pretty cool. And here you have my Twitter handle. That's where I'm most active. If you want to reach out to me after this talk, just write me a DM or just tag me somewhere, and I will get back to you. Yes. So yeah, about this talk, it's to get a glimpse at the Vue 3 reactivity system. It's not to, we are going to learn a little bit about the ES6 proxies, because that's the technology that's actually behind all of this. And we are going to also look step by step how this exactly works. It is not meant to understand the reactivity in full detail. There's a little bit more to it, but this is to get a very good idea why things work the way they work. And at the end, I will provide a GitHub repo where you can reproduce all of this at home. So it's there are different branches. So step by step, you can go to another branch where I add a little bit more of functionality. I think it's 12 steps. Some more than I do actually here. But there you can then at your own time take a look at it and really try to understand it, because there are a few aspects that you need to really look at a few minutes and then like, aha, this is how it works. Yeah, but I try to guide you through all of this the best I can. Oh, this is not okay. Surprise at the end. No, there's no surprise at the end. This was for another talk. My apologies here. All right. So what is reactivity? It is magic, right? We all love Marvel movies. It's magic, Doctor Strange. But is it? Is it really magic? I think it's, yeah, they say magic is just something that science can't explain, right? So is it magic? Maybe not, but if we are talking about science, yeah, since reactivity is complicated, it's rocket science. We have our good friend Elon Musk here. But is it rocket science? It's also not rocket science. Sorry, Elon. It is not that complicated, and we are going to take a look right now at how it works. So how does it work now? Seriously. Okay. Reactivity is when you change one thing and it updates wherever it's needed. So in order to do this, we need to listen to changes and we need to notify when a change happens. So this is called the observer pattern, and we just need to automate it somehow. And I will also show you how this works. All right, a little bit about the terminology I'm going to use. I will talk a lot about effects. What is an effect? An effect is nothing else than a function, like a side effect that happens when something changes. So it is just a function. So remember, when I talk about an effect, it's a function that executes something that I want to happen. Maybe update the DOM somewhere. Yeah. Okay, let's come back to this observer pattern. Yeah, we need to subscribe these effects, these functions, to a collection. So you can imagine a list or an array. In fact, we're gonna use set, but like a list or array or set of functions. So an array of functions, different functions, and these different functions are like the effects that we want to be executed when something changes. And we will see in a second how this looks like. And we need to execute all these effects when a change was detected. So we have this list. Let's say we have 3 effects for 3 things we want to happen. And if a value changes in an object, then these 3 functions are going to be executed. And then that is how our reactivity is constructed. All right, that's pretty cool already, but we need to automate it somehow. So we override the getter and setter for the object properties. And for this, we use the ES6 proxies in Vue 3. In Vue 2, we use something called object.defineProperty. And that came with a few caveats that with ES6 proxies, with this technology, we don't have. So this is an improvement on the reactivity engine from Vue 2 to Vue 3. And a little bit behind the scenes of the proxies. So this is what it looks like. At the top, we have like a normal object. I just see that it still says age 35. Yesterday, I had birthday, so now it would be 36. Anyhow, we have an object, like the top one is like the original object, and the bottom one is a proxy. So it serves as, so if we interact with the proxy, it does the following. So if we set a value, for example, the age here, it gives it back to the original target, as we call it. This is like the terminology we use. Target is just the original object, right? And the same when we read a property from an object, for example, with the console log or whatever, there it goes back to the original object and it reads it. The proxy gives this value back. All right, but the very cool thing here is this thing has superpowers, because this is called like we can override these handlers. So we can override the set method here in the object, like among other things, the set method, also the get method here. So we can intercept this, and we can leverage this to create our reactivity engine within these proxies. And we will build this from scratch, step by step, so you will actually see how it really works behind the scenes. But this is basically how it works. We have a proxy object we interact with our code, and this just puts it back to the original object or the target, and we can intercept these methods. All right, here a little bit about how all of the architecture is structured in the reactivity engine. We use the set map and weak map, and just a small note, we are only going to use in this example the first, so the right-hand side, the dep thing. So, but I think it makes more sense when I finish explaining this. So dep, this is the list of effects we talked about. So this is, it's just a function. This is what we already saw. An effect is just a function. So this is our list of functions we want to execute for when a certain property in an object changes. So these are all the effects for a specific property of a specific object. This is what we need to remember. And there are no double entries because it's a set. We could use arrays, but then we would have double entries. All right. Then we have something that's called a deps map, which is of type map. And the key here is just a string, for example, name. And the value is is a dep. So the value is a list of effects. And yeah, the key is a string. And these are the deps for each property of this object. So I will talk about this again when we have all of this finished, then it makes a little bit more sense. So here we have a target map, and here the key is not an object. Here the key is not a string. The key is an object, and the value is actually the a depth map. So this might look a little bit confusing, but let's go through it one more time. We have an object here, for example, the one that we see on the left below, with a name and an age, and this is the key. So we have various of these objects, as we would have in a Vue component, right? We have various objects with various properties and so on. Okay, so we want that only the things, only the functions are, or only the effects are executed that actually change, right? So for each object that we have in our component, for example, we have a depth map. So for every property, we have a list of things that needs to be executed. For example, when the name changes, there's another list of effects that need to be executed than when the age changes, for example. And this is how the Vue 3 Reactivity engine architecture looks like. So yeah, again, to summarize this slide, for each object we have a let's say a list of or a map of for each property, and for that we have for each property we have a list of effects or functions that need to be executed. All right. This is another terminology I will be using, tracking and triggering. Track is for registering an effect, and trigger is to notify about changes. All right. And now it's time for some live coding. Let me just get out of this. Okay, this I won't need for now. Yeah. Okay. Cool. So this is my the project that I set up. This is just an HTML site, and we have some styles here just to make it look cooler. So we are on brand with WeAreDevelopers. We have some text here that for now is not important for us, but what is interesting for us is this script, which is a reactivity.js file, which for now is empty. I also have the full version of what we are going to code here. So just to take a quick look, we are going to code some of this in this session. So not all of it. There is some things that we can skip because it will just be too much, I think, for a single talk. But this is what we are going to do. We are going to create a track, our track function, our trigger function, and our reactive function, and our effect function. What we are not going to implement is ref and computed, but at the end I can go over this so we understand what's happening here if there's still time. But this is for later. For now, we are going to implement all of this on our own. So I have a live server running here. So every time I change something here, I save a file, we see it on the right side. So let's just see if this works. Hello, developers. Okay, so the console works. Let me maybe just zoom in the console a little bit more. Okay, so this works. Okay, let's start very slow. We are going to create an object. Let me move the mic a little bit. Let's call it product, and it has a price, 6 euros, for example, and the quantity, 2 of these. And we want to calculate the total total is the product price times the product quantity. Okay, let's log this out. The total is, okay, so this works. This is already cool. So now when we update something, product price is, let's say, 7 instead of 6, and then we log it out again, we have our first problem. It's not updating, as we can see here. It was 12 and it stays 12. So we need to do this. We need to execute this again here after we update it here, and then it works. Nice. And now we want to update the product quantity plus, and we log out the total, and we have the same problem as before. It doesn't update here. We have to copy this again, and then it works. But as developers, we see, yeah, this is a lot of repetitive work, something that we can refactor a little bit. So let's start refactoring this this code. So let's create a function. Let's call it calculate total. And we just recalculate the total here. And then we can put it to 0 to start with. And then every time when we calculate this here, we replace it with our calculate total. All right, so yeah, the first one is 0. So before we do anything, we also have to calculate the total. And then it works again. At the beginning, it's 12, then 14, because we updated the price. Then the quantity goes up, and then it's 3 of 7, so 21. Neat. But still very manual work here being done. We just moved the problem to another, it looks a little bit cleaner, and we have a function, but it still isn't great. So let's program our trigger and track function. So track and trigger. So if you remember from the slide before, the track is it registers an effect, so a function that we want to execute, and then the trigger is that we execute all the functions there. So this actually takes target key, is also target key. So in this example, we are not going to use the target and the key. I just put it here in order to, so you can imagine what would happen here. But for now, the example we are going to code out today is for everything that changes, everything, all the effects are going to be updated. And then later I will take you to the full version where we put some restrictions where actually only we update what's needed, right? But okay, so track, we need to add something to our list here, and we said it's called dep. So dep, and this is a new set. And we just need to add it here. So dep.add, and for now we will add here the calculate total. Oops. And we leave a note here to our future selves to do remove hard-coded effect, because this we will do it dynamically. But for now, this is good enough. We add when we want to track something, we add it just to this list, to this set. Okay, so this is done. And here in the trigger, remember, we need to execute all the effects, all the functions we have in this list or in this set. So we just go in this dep, which is a set, and this has for each. What's inside is an effect, and what are we going to do with this effect? Well, we just execute it by calling the function as such. Okay, so what do we do with this now? So we can do at the beginning, do one track And then after every change, we do a trigger. So after the calculate total here, we do trigger. Let's just save this and see if it still works. Yeah, okay. It works, but the first one again not, because it's not triggered. So we need to add this here, trigger, and then it works again. So we have some sort of mechanism behind this, but it is still a very manual thing to do. We need to put track and trigger manually here, and it's just not cool. This is not scalable, not maintainable. So we are going to do something more dynamic. So this is where the ES6 proxies come in, and we are going to code them out now. So let me first show you how proxies work, and then we are going to integrate all of this into our proxies. So I will delete this example code here, and let's just create a product proxy. And this is just new, this is syntax, right? New proxy, and we pass the target here, which is the, as I said, the original object we want to work with, so the product. And then we pass something that's called a handler. I will talk about this later, but for now, let's just look how this works. This is a proxy. We are supposed to be able to interact with it the same as with the original object. So let's say product proxy dot price is, let's just log this out first. Log out the price, and then we update the price to 7, and then we log it out again, and then we can see it works. It really updates. We can do the same with quantity. Product proxy dot quantity plus plus, and we log it out, and oops, not the price, the quantity. So it was 2, now it's 3. We can also log it before doing this. Okay, it was 2, now it's 3. So this works as expected, but I told you here is a handler, and here we can, in this handler, we can override these getters and setters we saw from the slides earlier. So let's just say I override the get function here, and I just implement it as empty. What do you think happens? Yeah, undefined. So every time now when we read this, when we want to get the property from an object, well, it returns nothing, because what we do now, we broke it. We overrode this. This is not an addition to the original to the original getter function, but it is actually replacing it. So how does this work? Let's say we return here 1, 2, 3, and this is actually what's going to be returned here. Okay, just hold on. Okay, so now what we have to do, we have to actually return the right value. So the result. And what is this? Let's log this out first. Let's log out the, for example, the product here. Let's just take a look what it is. So the product is the original object here, nothing else. And but just let's keep a log here, get, and then what do we get? This actually takes some parameters. So target, yeah, target and key. So this is get key, and then this happens. Get price, get quantity, get quantity, get quantity. So we have the price here twice, and quantity. So every time when we use actually the get, this gets called. Okay, so now we just need to return the right value here. Let's calculate it here. The result is from the target, so from the original object, the property, and this not much more to it. So now we have the correct result again. Nice. All right, so we leave this for now here. Let's maybe just leave the logging in here, get key. And then the same thing we can do with the setter function. So we set target key, and we also have to put a value because this is the new value we're going to assign to this property for the object. And here, let's just execute it like this. And what you can observe now is that we update the price here to 7, but it doesn't really update because when we log it out down below, it stays 6. It doesn't update to 7. This is, again, because we overwrote the whole thing. And now, before we do anything else, we need to fix it. So let's log out first to see what we are working with. So we set the key value. And this is exactly as expected. So set the price to 7, set the quantity to 3. So this is the new value that's going to be set. All right. As a return value here, we don't need to return any value. It's just we need to in the original version. We need to return if the operation was successful or not. So let's just assume it was successful and return true. Okay. Now we need to actually update it. What do we need to update? We need to update the original object, so this target. So we need to override, well, not to override, to do an operation here on the target, and target with a specific key, and we set it to what? To, let's say, 9999, and then all the values that we set are just going to be set to 9999. We don't want that. We want this value. We just replace it here, and sure, everything seems to be working again. Nice. Okay, so now comes the thing where we actually combine the two things we did right now. We have the track and the trigger functions, and we have this proxy. So this proxy, let's just wrap it in a function, or let's function, and we call it reactive, right? We pass a target. Let's move this up. And yeah, I told you this is called a handler. Oops, let's just call it as it is, handler, and we extract it out here. Okay, and arrow, yeah, product proxy. So here we don't do this, we just return the proxy because that's what you want, right? You want to have here, we will do something like this. Here we will put the reactive around this, which should make it reactive. So we don't want the original target, we want the proxy. And instead of here the product, we just pass, we just put it, we just pass the proxy, the target that we pass. So we have a little bit more, we are a little bit more dynamic. And I'm going to remove this code because it's going to throw an error because we don't have a product proxy anymore. Okay, so now when we do something like product quantity, we would expect it to output like get the quantity, right? This doesn't work yet because we didn't make this reactive yet. So let's just pass the original object to our new reactive function. Let's go through it one more time. We pass an object here, in this case, the price and quantity. This goes here as target. And we intercept the getters and setters by creating, we put those in the new proxy and we just return it. So now we have this set, the reactive, right? So we have product.quantity. Let's just read it out. So we use get. And yeah, it works. So get the quantity. And we can also plus. Then we are going to also set the quantity. Okay, nice. So now we can actually implement or add these track and trigger right here. So what would we do when we get a value? We want to make sure it's tracked, right? So we just do here the track, and here the target and the key. Again, we don't use it, we don't implement it fully out here, but just so you see how it could look like. And then when we set a value, we want to tell our application, oh, hey, something changed, and we need to trigger all these effects, right? The list of the effects. And here we just say trigger for this object for this key. And then the trigger also takes the target and the key, and it finds out which effects need to be executed. As I said, in this example, we will just execute all the functions, all the effects. Okay, so let's just remove these console logs, and we add them here to the track and here trigger. All right, so now what should happen is when we product price, it should be triggered. There should be it should be tracked. That works. So it's tracked. Now it's in the in this list, right? In this set. And when we override it, it's also triggered. Nice. So when we do it with quantity, it's it's also triggered. All right, so now we have a pretty good, we are already a little bit further, but there's one last part missing, and this is to make all of this a little bit more automatic. So we are going to write a function that's called effect, and we pass a function to it. And just let me show you what I want to do with this. I want to do this. And here I want to log out, for example, the total changed to, and then the total. Hold on. Yeah, okay. So this is what I want to do. So now obviously nothing happens, but this is no, actually we want to do this. We want to calculate the total. We want to recalculate the total, and this is how it works. So when this effect thing, this effect function is it detects which properties of which objects are being used, and then when it's used here, the getter is being called, so it's going to be added to this list, and then when something changes, this effect needs to be executed. So this is what we are going to do, and this is where it might not make sense right from the start. It might make sense when you take a look at it later, but this is an active effect. We initialize it with null, and this is what we're going to do. So the active effect is the function that we pass here. So this basically. Then we execute it, and then we set the active effect again to null, and this is where it gets a little bit trippy. So let me try to walk you through it. We have this active effect value. We go into effect, we pass this function, then the active effect is going to be this function, and then we execute it. Why do we execute it? We execute it because in order to get in order to track these values we used in here. So the price and the quantity, they need to be tracked, and this makes it all automatic. And then we execute it, and then the track is going to be called, And here we can remove our to-do. So this is not going to be calculate total anymore. It's going to be active effect. And we just do this if there is actually an active effect. So it's going to be looking like this, and let's move the active effect to the top here for measure. Here, okay. So we see that already something happened. Here it's 2 tracks. Why are there 2 tracks? Yeah, because we execute this. When we executed the getter is going to be used. So it goes here into the getter, then it's being tracked. That's why there is track. And then when we use product dot quantity is 6, it's also triggered. So total changed to this. So this already sort of works. This is a reactivity right here. So if we change the price to, let's say, 100, we should get 600 because now the quantity is 6 and the price is 100. And the total changed to 600. Great. In order to visualize this a little bit more, let's just take all of this code here. This we don't need anymore because we have it at the bottom. And we just use this. Just copy it down here. So if we remove this, I will cut it out. And if we take a look at this, it's looks like almost like a library, right? We have a few things like that are being used internally, like this depth and a few functions that sort of work together. So it's like a library. So we just leave it as that. And here in our index HTML, we just add another script tag, a script tag, and then we just execute it here. And this starts to look more and more like a Vue file, right? So we have our markup, our template here. We also have a script. And let's just let me just show you a little bit how this could work a little bit more visually. So let's put how much time do we have? I might go bene like 5 minutes over time, but then I'm done. Don't worry. All right, so I will try to speed this up a little bit. Let's replace this with the total and dollar, and we have a span of the ID total. Let's put the value 0 there from the start. So this is how it's going to look like. And instead of logging out this, we can do something like document.get element by ID total. And we just set the inner text to our new total. Just a small note. This is not how it actually works. We don't manipulate the DOM directly. We use a virtual DOM for that. But that would be a little bit too much here. This is just to demonstrate it. And if you're interested in virtual DOM, I will be giving a talk about the virtual DOM, how it works in the inside, the talk exactly like this, building it up from scratch in Vue.js Amsterdam next week. So if you are there, that will be the continuation talk from this. And I think it's also going to be recorded, so you can take a look at it later. All right, so here, yeah, so this works, and we want to manipulate it. Let's just give this DOM a few buttons, plus button, and the on click. And here's where it gets interesting. We just set the product quantity plus, and we do the same with the minus. So this really looks like a Vue file almost. If this was an at and not an on, then it would be very similar to Vue. And let's see if it works. It actually works. This is pretty cool. And one last thing, Ben, and then I'm done. Let's do something cool. Let's add here a color. Let's call it hot pink. And let's register a new effect. this is a function, and when the color changes, so document dot the body, the style, and let's just set the background to the product color. So again, we have an effect here. Now it knows when the color changes, we want this to be executed. So it replaces the background color with this color. And we just need to have an input. So a color picker, not a text, so color. And on input, we just overwrite. Again, we don't do anything directly here on the DOM. We just say the product color is this.value. And it seemed to work, at least at the beginning. And then we just remove this, and nice. We have the Reactivity engine here doing its work, updating the values with a few lines of code here. Let's remove the console logs. Yeah, 32 lines of code with spaces, so 30 lines of code. A very basic Reactivity engine right here. And that's basically it. I wanted to show this file also, but I think there's not enough time. I think you profit more from it when you go here and scan this. It's a link to GitHub where it's shown step by step. So thank you everyone for listening to this talk. And also thank you, Bene, for having me here in the live show, in the Vue Day. And yes, I'm done. And let's see if my AirPods started working again.
Marc, hello again. Thanks for the awesome talk. Also awesome that you are using VS Code. It's also editor of my choice, so always happy to see that. All right, so we got some questions, and if you are ready, we can jump into a quick Q&A.
Yes, let's do it.
Let's do it. Maybe first one, you are developer, you are speaker, you are DevRel lead, you're brewing your own coffee. So maybe you want to enlighten us a bit about your journey, your development journey, how you started and how you got here where you are now.
Okay, yeah, how I got started, if we go way back when I was 15, I could choose here in Luxembourg, you can choose almost like a profession. So in school, you go in a certain direction. I chose computer science, you could choose mechanics, science, whatever. I chose computer science. And that's where I got into it. I learned coding there. After that, I went to university, did my bachelor's and master's actually in Austria and in Vorarlberg. And after that, I went to work, very strange turn here, going to Mexico to work in a university, developing their university system. Everything was paper and pen. I wrote them a web application to manage their entire school, the entire university online and on a system. I worked then for a few years. That was with Ruby on Rails. Then I worked for a few years for a German company that offers chat solutions for enterprise clients. Like if you know, in Germany, the Sparkasse, 2/3 of the Sparkasse are working with the product that I helped develop. And I worked for 9 months, I think, for Vue Storefront as developer advocate. I didn't really like the e-commerce world, so I quit there, and I found this amazing job as DevRel lead here at WeAreDevelopers. That's my quick journey.
So happy end after all.
Happy end after all, yeah.
Since I know that you speak very good German, did you understand the people in Vorarlberg during your studies there?
At the first 2 or 3 months, I had really trouble understanding it. I didn't understand much during the courses, but after that, I got used to it, and I started understanding more and more, and I even sort of talked it afterwards.
Perfect. Thank you so much, Marc. We got a question. is using proxies performant enough? Does it not kill a lot of memory in huge apps?
No, it's performant enough. It's I've seen Vue.js or Vue 3 being used in large apps, and there is no performance concerns when it comes to the reactivity system.
Perfect. Thank you. Another question. So basically, the trigger function gets called every time a property of product changes? Question mark.
Yes. Yes. Exactly
Short
right.
answer, yes. Okay, perfect. Marc, you also joined some of our World Congresses in the last years. Maybe do you have some memories from there that are share-worthy?
Yes. I attended actually the first time last year, 2022, in what was it, June, I think, or July?
It was
June.
late June, yes.
Late June, yeah. And first I was like overwhelmed by the venue. It was a huge venue, and something I didn't expect. I met many people there that I know from Twitter. So people that I just met online, and we just hang out and we sort of talk like we were old friends, because we talk like on almost a daily basis. And I think my very favorite memory is not from the Congress itself, but from there's a photo about this. I think with 4 or 5 people from Twitter that I knew from there. We went to how is this burger place called again? The one where you have to sort of make your own. Five Guys. We went to Five Guys, and we just had a burger. I think that was one of my favorite memories from the whole year, and that happened at the Congress. So basically,
Also,
meeting people, networking, and so on. My favorite part.
Yeah. I also remember the Five Guys from Berlin. Precious memories. So more technical question. Is there something to keep in mind when having nested objects?
When having nested objects, yes. In Vue, you can provide the property, or in the watcher function, you can say deep true, and when you do that, the nested properties are also triggered. So those don't work with the solution that I showed you today. So you have to use the deep true. Just use just look in the Vue docs for watch or watcher deep. You will find the syntax there, and then it will also work with nested properties.
All right, thanks for that answer as well, Marc. Another question. Would this be also a proper layer to introduce some kind of memoriation to limit the unneeded effects?
Okay, can you read it again, the question, please?
Would this be also a proper layer to introduce some kind of memoriation to limit the unneeded effects?
So I don't really understand half of the question, but I think I know where this is going. I think this is going. It talks about unneeded effects, and we just need here unneeded effects because this solution isn't coded out fully. If I go, can someone just turn on my screen again? Yes. If we go here to the full version, here we go through sort of filtering actually for each object and so on, and for each property, that only exactly the effects that are really used are or that are really needed are executed. Others are not executed with this. I think it makes sense to take a look at this repo and take a look at the final version, step 12. There, everything is completely coded out, and here we have this depth map and this target map as well to take into consideration. So there are no in the final version of Vue.js, at least, there are no unnecessary effects. That's basically it.
All right, thank you so much, Marc. We got another question. We built this in 30 lines. Vue reactivity probably is a bit more sophisticated. What would be some improvements to be made? I'm thinking of only update when what needed or similar.
Yes, this comes down to what I just talked about now. It's the target map and the depth map that are not implemented here. So again, when you take a look at the repo at the final step, I think even at step 10 or something. After that, we just implement ref and compute it. But at step 10, at least, there should be the track and the trigger be implemented in a way where it takes into account like just that for this object, for this property, then we have like this set of effects. That's like the biggest thing that's missing here. And that would, make it way more performant.
All right, thank you, Marc. Another question. How is it possible or easy to know which objects are reactive or proxied in a huge Vue.js source code using an IDE like VS Code? I'm coding from C++ or Java world. Is it easier when using TypeScript?
So you want to detect which object is a proxy? That's actually a good question, and I might not have an answer to it. Just let me try something.
Now we come to the real life coding.
Yeah. So I just want to see if I just want to see if it recognizes that the proxy is no. Okay. I might have to look this up. I can't tell you for sure, but there should be a way where you can find out which one is reactive and which not in a huge Vue project. And actually, I think most projects don't really use reactive; they use ref. But even there, I couldn't tell you how you can find out what's reactive, what's not. That's a good question. I would have to look up how to find out which one is which.
We'll be in contact about that.
Yes.
All right. And the next question I can answer myself. Is it possible to watch the session afterwards? Yes. Right after the session ends, you can watch the whole stream on YouTube and maybe also check out our watch section on WeAreDevelopers.com as we upload every talk separately there, also in the different categories, so you can watch past talks as much as you want to. So thank you, Marc. And before we go on, just a short 30-second break. And right back to Vue.js. Oh, Marc, you're still there?
Oh, yes.
Yeah. If you like it so much, I'm really jelly of your VR headset, and I would need some time to check it out myself. Would you mind taking over the moderation for the rest of the day?
Sure. Yeah. Sure.
Marc, thank you so much.
Let me just pull up the website. Let me pull up the website and see who's next. And here we go. Yes. I can,
thank you so much,
do
Marc.
this. Take the headset and have some fun, Bene. All right, so cool. So we are here now. The next speaker is Ramona Schwering. She is a software developer at Shopware, where she's now for 6 years, where she worked in quality assurance and software development. So she has the view of the two worlds. And it's not surprising that she's going to talk about visual testing. Welcome on stage, Ramona. Yeah, you're muted.
This is the default mistake we do always on screen, I think. Yeah.
Well, hey, Ramona, nice meeting you again. I think we met in two events last year in Vue.js Amsterdam and in WeAreDevelopers World Congress.
Exactly.
And I think I never saw you without a mask. So it's nice to finally put a face to your person, because it was always still with a lot of issues with COVID. And it's very nice seeing you, Ramona.
Thank you. Likewise. And yeah, I'm not that strict anymore, still in crowds, but yeah, I guess it's better now, and even on in-person stuff.
All right. So can you tell us in a few sentences what we are going to learn from you today, Ramona?
Well, it's basically giving your test eyes, which sounds kind of strange, but it's basically the thing you do. If you are a human being and look at a screenshot, an application, or a search puzzle, you look for differences, and it's basically really easy for a human to do that. But we want a test to do the same, so you don't need to be limited to the things you describe or you really assert to in the test, but everything else.
So we are talking a little bit about like when the layout changes without us wanting it to, that there's automated tests for this. All right. Yeah. So I'm certainly intrigued. I hope everyone else as well. So without further ado, Ramona, the stage is yours. Have fun.
Yeah. So again, hello, and thank you so much for taking your time to listen to me here at the Vue.js Day. I'm so glad about that, especially as it's kind of early in the morning, I think, at least for some of us. But, well, just take a seat, take a little coffee, and let's learn about visual testing, or at least my journey to visual testing. Some small facts about me: I'm working as a software developer at Shopware for like 6-7 years now, mostly front-end focused. But I also have 5 years of experience in the quality assurance. So as you might have guessed then, I'm quite passionate about test automation. So I organize meetups for it and became a Cypress ambassador. And apart from that, I'm a Google developer expert in web technologies and a woman TechMaker ambassador. But I guess I'm the least important person here in the room, so let's finally get going with my topic. Well, I guess besides of being developers or in tech, we're all users of websites, users of apps. And sometimes, I guess, in our daily doing, we encounter certain bugs, like bugs which are not release blocking. It might be a small UI errors or some typos, just looking plain ugly. And you can find them basically everywhere, and they leave a certain impression if you ignore them, or if you as a developer, and us as a developer, if we don't fix them. See this one. It's a little screenshot from an iOS device, and it says keine Mitteilungen, or in English, no notifications. And it's just broken, right? So it's doubled, it's not at the right place, it's just broken. But this is not the only point where you can encounter such bugs. It can also be at many larger companies, at many large applications. Let's take a look at Google, for example, where you see here that the button is at the wrong location in the footer, or Facebook, where a button has wrong padding and just looks broken. And these are just 2 examples of many, many, many examples. And it's nothing usual, but I still think they are problematic. And it's not because I'm a perfectionist. I need to be guilty on that one. I always, if I see such bugs, I always wonder one thing. And you should wonder too, would you trust those apps? Like, a website with lots of user interface errors, which looks broken, which doesn't show any sign of care, would you trust such an application, especially when it comes to e-commerce or entering your credit card data, if they don't care about such small issues? Especially considering the following fact that those errors, do you think they are quickly fixed? No, because they do not break functionality. They don't block a release. They are just like white noise, right? And even if developer teams focus on getting those issues away, it will keep those teams away from developing new features. So either way, it's a growing technical debt. And trust by the users will be lost over time because the application will still look broken, right? Well, we as developers, do you think we are really to blame? Because obviously someone did introduce this error, this issue, and maybe someone, as a developer, as a tester, whoever didn't notice it. Are we to blame or not? Well, we are all humans, but we still should think about, is there much we can do about it? Is there a way to improve our shortcomings as a human? So, in my opinion, we are not completely to blame because there's a well-known phenomenon in psychology, which is quite famous for, some traffic campaigns in the UK, for example, used it, like the famous Who Done It by Do the Test, the videos. If we have some time left, we could maybe take a look on it later on, or I'd send the link in the chat later on or something. But there are many examples where such a interesting phenomenon is showcased. Like the one which I remember first is from my student days, where we watched a video and we were tasked to count all the people in it. There were some people divided into two teams wearing black and white shirts, and they passed balls to each other, and we should count those passes. And you might have known, but if not, like almost half of the audience, of the spectators, while counting those passes, didn't notice that a person in gorilla disguise broke through the picture and danced and did stuff. So basically, TLDR, something really obvious for a human eyes, but many people don't see it. This is called unintentional blindness, or in detail, it's a situation where a person fails to notice an unexpected stimulus in the vicinity solely because of the lack of attention, because we just don't think about it or don't take attention for it, and not because of visual defects or deficits. So we are seeing such obvious things, but we just don't take any notice of it. Another good example is, for example, my designer friend who oversees a huge typo in the title of his banner because he's so focused on details. Yeah, this is really human. But now you could come up with a question like, for human shortcomings, don't we have good test automation? Shouldn't they catch such things? Don't unit testing, integration testing, E2E testing is already enough? Shouldn't they prevent us from our own failures? And sorry to disappoint you, but in my opinion, they don't. Because all those normal test automation types only test what they are supposed to test. I like to phrase it as end-to-end testing doesn't look left or right. They do only the things you've written down in your tests, and all other things will remain undetected because they are not explicitly written down. And this is valid for basically anything outside the context. Some not intended changes in the user interface, side effects, many mistakes or errors will remain unnoticed in this regard. So, okay, we now see the situation is a bit tricky to approach because we cannot just use humans for manual testing all the time, right? Isn't there still some way to solve this situation, this problem? And as said before in my introduction, we need to teach our tests to act like a human, basically giving those tests eyes, like we as a human being do automatically. Packaged in words, we want to do visual testing. So what does this mean in detail? What is visual testing about and how does it work? Well, imagine a spot the difference puzzles. I myself, I love to do them in my childhood. And if you take a closer look at it, there are 3 differences in the one picture on the right side. So can you spot them? Well, I won't waste too much time, so don't worry. The first one is here. The wearing cap is turned differently, like in another angle. The miniature figure here, the pixel link, is on the other side of the picture frame. And completely in general, the complete picture was shot at a different angle. And yes, as human, we find those differences kind of quick. But I want the test to do exactly the same, to see those differences. And it's basically a screenshot comparison, which I want to achieve. Like we take a basic screenshot from our application or from our main branch as a status quo. So this is basically the correct screenshot, signalizing everything which it should be. And then we take a new current screenshot, for example, from our implementation, from our feature branch, wherever we run those tests. And then we compare those screenshots and highlight the differences in it. And this goes further than just snapshot tests you are maybe used in your component testing. And when we have such a difference highlighted by a screenshot comparison, we can decide whether this change is desired or not. And most tests don't do this by themselves. How could it? Of course, there are some tools which have some machine learning in it, but in my opinion, we still need a human with their intuition, with their creativity and knowledge. So it's not enough yet. So a review is still necessary by a human, and the human will decide if the difference you see in the screenshot comparison is valid. Like, for example, we introduced a new feature, so of course there will be changes in the user interface, or if it's something we didn't intend it. All right. Of course, you could say, okay, let's write this by ourselves. We have lots of testing frameworks like Cypress, Playwright, Nightwatch. We can already save correct screenshots by creating those in the test and compare those with a library, for example. But is this feasible? Not always, because there's lots of maintenance connected to it. You could get many false negatives due to pixel sensitivity, minor rendering differences, or differences during loading. Of course, you could add some blur via the libraries or some fuzziness. But do you really want to decide by yourself how much is necessary and how much fuzziness would be too much, so you are basically hiding errors? And of course, you need to keep the screens up to date, which can be helped by framework, but still it's some effort. So let's take a quick look on the tools for visual testing, which you could take a look at. There are many ones like Applitools, Percy, Chromatic Bay, Storybook. But even more interesting, at least in my opinion, some open source implementations or custom ones like the Visual Regression Tracker or the Cypress Image Snapshot tool, which is not only for Cypress. I guess there are some other ways or possibilities like the Just Image Snapshot, or I'm not completely sure if there's one for Playwright, so it doesn't need to be completely Cypress, but still many custom open source plugins are available as well. And in this session, I will present you my 2 favorites, which I use most of the time, basically. Of course, I will use Cypress at the moment as a way to showcase my examples, but you don't need to be limited to Cypress as said. So you could think about using Playwright, even Selenium if you want to. So although 2 frameworks I will like to showcase are introducing support for many frameworks, so don't be worried about that. So my favorite one basically is the Visual Regression Tracker, and I will use PerCIO in this talk as well, because yeah, basically both are tools to manage the results of visual tests. So where you can basically decide if the difference you see is valid or not. So the approval workflow or the rejection workflow. And as said, both are automation framework independent. I will start with the visual regression tracker because it's open source, and I'm a huge fan from open source. Well, Shopware, for example, which is my employer, provides an open source e-commerce solution, so I'm working in open source basically all of the time, and I like to contribute and give back. So I would like to focus on this tool, and it's self-hosted, so I can have control. I love to have control, and it uses Docker, and I love Docker. As a complement, especially when it comes to larger projects, I will use PerCIO because I have some experience when it comes to Percy in larger projects. Just to showcase basically the whole range you can do with those tools. All right. The installation basically is fairly easy for both tools. Of course, if you don't use a software as a service solution as Percy is, for a visual regression tracker, you will need to set up the approval service first, or the backend service, or however you want to call it. And you will need Docker for it, so make sure that you have Docker installed beforehand. And then you can basically download the installation script and run it. And then you're done for the div management service. As far when it comes to the integration to Cypress, it's a default plugin workflow, so you can install it with npm, for example, or another package manager you're comfortable with. All right, so I captured the setup for the visual regression tracker in a sample project, and we can quickly take a look. So at first, I will add the commands, which is kind of basic for a Cypress plugin. So I will import here some commands, like anything which I need, which is like starting the tracking, doing some screenshots, and so on. And then we will add basically a plugin. Beware, this is the workflow for Cypress version below 10. I will cover 10 plus later. So you can still use this plugin file in Cypress 10 if you use the certain migration path, but you are not obligated to do it, so don't worry about that. So yeah, it's the typical Cypress plugin edition workflow, and I hope I'm ready with talking or finished with typing fairly soon. And there we go, soon. After this, we are just doing some configuration stuff in the Cypress JSON or Cypress config file. This JSON file is, of course, Cypress below 10. We will cover the 10 plus version in a second. So these configuration could be current branch name, URL for the backend service where you do the approval workflow, API keys, stuff like this. Yeah. And then we will take a quick look at the tests. Here we enable the visual regression tracker and starting it in the before hook, and in the after hook we will end it. And then it's just basic command usage. So if you want to capture the complete page, you can do it like a typical parent command here, as you saw. But you can capture individual elements as well. So in this case, you can use it as a child command. So you get the element, and the yielded element will be the one you will screenshot here. Yeah, and that's basically it. In this case, you are done when it comes to the usage. A small addition for Cypress version 10 and higher, I'd recommend you to use the configuration in an own configuration file, typical for the visual regression tracker, so you don't need to rely on the old Cypress JSON anymore. So in this case, this is the difference you need to take care. But I can link you a little project later on where I configured this visual regression tracker for Cypress 10 and higher as well. So I didn't manage to do a little QR code here, but I can send you the link later on. When it comes to the Cypress test runner, you can take a look how it looks like when those visual testing will be executed. And then, as you might have guessed, when it comes to the implementation in the tests, it's still a basic end-to-end test in this regard. So you do some typical Cypress stuff, and the capturing of the screenshot is the basic Cypress screenshot command. I underlined it here. And there's one thing to take into account. If you run Visual Regression Tracker the first time, the test will always fail. And that's completely fine because you are collecting the baseline screenshots here, the status quo, and you need to accept those as being correct. So this doesn't mean that your test is really failing, just that you need to add them as a verified baseline, basically. All right, so far for the Cypress test runner. This is how the div management looks like in Percy itself, so the Percy backend service. So it's a basic approval workflow. You can accept your screenshots here or decline them. And on the left side, there's the baseline. So here you see the correct status quo screenshot. And on the right side, you will see the new screen from your implementation. And you might have seen already, there's a slight difference we have. But if you want to see it even more exactly, you can highlight those differences in red if you want to. So, for example, for smaller rendering issues, this can really help you to find the difference and then deciding if you want to accept it or reject it. Okay, now you know Visual Regression Tracker with Cypress in smaller projects. And I love to use them there because I can host it myself, it's self-hosted, it's open source, it's independent. But to be honest, I don't have that much continuous integration experience when it comes to the Visual Regression Tracker. So let's take a quick look at one showcase for a larger project. An example from my everyday life with Shopware, which is basically having a big part implemented with Vue.js. So here I'm pretty sure that it will work well with Vue.js. Of course, the Visual Regression Tracker does it as well, but I only use it for smaller thing like my blog, which I built based on Nuxt and stuff. So let's take a little look at it. So in my everyday life, I worked with Percy.io in the Cypress tests, and I built the visual test pipeline for the Vue.js part of Shopware, which is basically the administration UI of this online shop. And the advantages I saw with Percy were that it was easy to integrate this tool with our pipelines. So this is why I'm quickly mentioning it as a compliment. There's a free plan if you want to use it in smaller projects as well. And many, if not all plugins by them, but I'm not completely sure about this, are open source. So at least they can still stay a bit open source. Like, it's just that there's a software as a service plan connected to it. So it's just the second choice in this regard. Percy.io is part of Browser Stack. So if you like to use a Browser Stack integration, it's fairly easy. And you can cover responsive and cross-browser testing as well. Well, when it comes to the continuous integration in my daily doing, we have an own job for it in our pipeline. So basically a visual testing job, which is apart from the end-to-end tests. You could mix it up, so you have just like one job for end-to-end testing and visual testing alike. But I like to divide it for certain reasons. For example, I only want to run visual testing at night on regular orders. So there might be some changes, like fixing a typo or some backend related changes where I don't want to kick off a complete visual testing pipeline, right? So this is basically my main reason why I split it. I want to run my E2E tests, the basic ones, only basically anytime, also on merge request, but not the same for the visual regression. I would advise you to still provide an opt-in possibility on your merge request though, so the developer can still decide if he wants to run visual tests or not. Well, the integration is kind of flawless actually, at least when it comes to GitLab, which I'm using at my work, or GitHub Actions, which we will take a look later on, which I prefer in my free time. So only a token must be set, and otherwise just, again, default plugin installation. And you don't need to be limited to GitLab or GitHub. There are other CI/CD providers supported as well. So yeah, I just tried out GitHub Actions and GitLab the most. All right, here's a little example of a GitHub action from the Percy docs. It's fairly easy to set up if you run Cypress Run, for example, or stick to the other guidelines of your other test automation frameworks. And Percy themselves will come with some pre-configured actions. So in my case, in both cases, like with GitLab and GitHub Actions especially, it worked basically out of the box. And the logs look basically like this. So you have some small Percy entries in it where you can see what Percy is doing, like taking a snapshot or loading them up, and it will already give you access to the build, to the change management. Yeah, and of course you can connect it to a merge request in GitLab as well. So the build is accessible via the job, so you can basically use an external job for it. And as said, I highly recommend you to use opt-in, for example, by setting a label on your merge request or something like this. And it's natural, but I still want to mention it. If the pipeline is red, the merge is blocked. And it's only turning green again if you approve the differences. And if you reject those, the pipeline and thus the merging will stay blocked. All right, so the difference management looks fairly similar to the visual regression tracker as well. So on the right side, you have the baseline. On the left side, you have the difference. And there you can accept the build or decline it. Another thing which I highly recommend you, independent of the tool, I would always set up some notifications to your development team, especially if you run visual testing on a nightly build, so like every night. So this way, testers and developers are made aware and can react to those differences. Can be done via Slack or with other solutions you're using. Okay, so that sounds quite great, right? So my basically daily experience, especially in the Vue context, is fairly good when it comes to visual testing. However, when there's light, there's also shadow. Even with wonderful test automation, even in the Vue environment, which is really, really great, there can be some difficulties and pitfalls I experienced. But I won't leave you out in the blue. There will be some solution, of course, so don't worry. I don't know if you know a certain story, but I think it's perfect to showcase the typical problem which I have in visual testing. It's a typical problem for end-to-end testing as well, but especially in visual testing, it becomes obvious. And the story I would like to use as an allegory is The Boy Who Cried Wolf by Aesop. Well, whereas a little boy shepherd who is tending to a flock of sheep and is bored and tries to basically play a prank on people by calling out for wolf attack without a wolf being there. So there's a false alarm, it's a prank, and the villagers who came to defend him came from nothing. But at one point where a real wolf attacks, nobody comes anymore to defend himself and the sheep. So the sheep will be killed, and yeah, nobody believes in anymore. And I like to use the story as a mean to explain flakiness. So a test which fails or passes without anything changing in between. And this can also be the case with visual tests, like it displays a certain change, but it's no error. It's, for example, a loading screen because we didn't wait too long enough and stuff. So it can be fairly obvious when it comes to visual tests, and we don't want to be crowded with some notifications for errors which are not there, right? But not only this flakiness can be an issue. We can be annoyed by false negatives as well. So basically, an error or a difference which is basically always there. I will showcase some examples in a bit. So I'm referring to natural changes, which are no error to begin with. But these are also changes that cannot be prevented. So all those natural changes shouldn't trigger an approval workflow, right? Shouldn't notify us. We don't want to be informed unnecessarily, do we? The perfect example for those natural changes are time specification. And I know I'm really annoying when it comes to time specification or time errors in testing in general. But here it's even more annoying because picture that we have a date in our dashboard in one of our applications, which displays a certain day, a certain time, a certain date, basically. And we run this visual testing in a nightly build. So there will be a change of date from yesterday to today to tomorrow. So this date will always change on a daily basis. And if you include hours, minutes, or seconds, this difference, this notification triggered by this difference will occur even more often. It's natural that the date is changing to the date to tomorrow, right? So we don't want to be notified of this one. So how can we approach this situation? Well, the easiest way of doing it is freezing the time on client side. I brought you a little example here with Cypress, where we basically decide for a fixed date, which we always want to use, and then use the command Cypress clock to freeze the system time to this date, and then continue like below. So yeah, we fake the time basically, which means, okay, we interfere with the test, but in this case, we won't be triggered for any date change at all. Another cause of flakiness, which I hinted a bit before as well, is this one, loading times. So what happens in visual testing if my website is still loading, if my component is still rendering, or the UI is still changing? In this case, we messed up a little bit in our tests. And we should wonder, am I really taking the right screenshot at the right timing? Is my app ready basically for being captured? So this is the first cause of flakiness, and it can be tackled fairly easy. We need to mind our assertions. We need to make sure that all loading times has been completed, that all the appropriate UI changes has been made before we create the screenshot. And we can use, basic assertions like the one here showcased via Cypress, but I guess most testing frameworks give you a way to dynamically wait for stuff. And I can't help it, but please don't use fixed waiting times ever. Okay, this is basically a general best practice in E2E testing. And I know I'm annoying with this regard, but it's really important. And last but not least, one example which was basically my nightmare scenario when it comes to visual testing a Vue application. Well, take a look at this screen. It seems like a normal login screen, right? Yeah, it's the login screen of the Shopware 6 administration UI. But there's more to it. This screen caused lots of unnecessary notifications and unnecessary screenshot difference, basically. Because this little image you see here, is randomly chosen from an image pool, and this image pool had different images in it depending on the time. So if you run the test in the morning, it might be different to in the afternoon, and even if it's the same morning, it could be different. So lots of unnecessary notifications. But it doesn't need to be this. For example, another occurrence, like a time specification of the server, like the time of an order in an online shop, which is often read-only because of legal stuff and this. So basically, things that change but cannot be frozen by the client because they are server-sided, they are read-only. And all of those changes, may it be the image one or this order time, they are by purpose. So we know that those changes will always take effect. Okay, how do we deal with those? Well, there are a couple of ways to do it in both Percy and the Visual Regression Tracker. You can basically set a threshold that gives some fuzziness, like when should it be triggered. So in quality, basically. But also you can ignore areas in the backend service of Visual Regression Tracker. So you can do it, basically in the backend service of Visual Regression Tracker, but you can also use configuration. For example, if you use Percy and stuff. So those look like this basically. So passing it as a parameter to the Percy snapshot command to pick the snapshot, or using a fixed configuration file. But you can do it apart from this framework independent as well. And there we need to be a bit careful, because in this case, I take the image example and I change it to a fixed one, to a fixed image, which always stays the same. And this means that I interfere with the tests a lot, which helps us to have consistent screenshots. But of course, we need to make sure with a separate own test that we don't hide an error by interfering with the test, right? And this is exactly one of the other reasons why I like to separate normal E2E tests and visual tests, because in E2E tests, I don't want to interfere with the test whatsoever. So in this case, we invoke some CSS and basically give another image in it. When it comes to the order time example, we could set the color of the font of the date to the background color so it appears invisible. So there are many different ways to influence the screenshot to be consistent. But as said, write an own test to cover it, and maybe think about documenting your changes or your interferences for fellow developers and testers alike, so they know that it's normal, that it looks that way. All right, so now our tests are basically detectives. So let's call them Sherlock Cypress or Sherlock Playwright or whatever framework you use. We were able to teach our tests to act a little more the way we humans do. And trust me, this can be a lifesaver when it comes to errors caused by side effects or some things you are not aware you're doing with your changes. As we can see, both tools, the Visual Regression Tracker and Percy, work pretty well for me in both small and large projects. It fits well into our infrastructure, and there are free plans, and both are, at least to an extent, open source. So might be a good idea to try them out. So let me quickly sum my talk up. So if there are 4 lessons I need to choose for you to remember from this talk, it's please try to give your test eyes. Teach it to look beyond the given path and make them act like they are solving a search puzzle or a spot the difference puzzle, basically. And this can be done through visual testing. So simply put, a screenshot comparison where you look for differences in between the baseline and your current changes. And if you can't get consistent screenshots, it's completely okay if you need to interfere but please beware to cover the original with another suitable test to not hide any errors. And if you need some starting points, some recommendation of tools, you could try out the Visual Version Tracker or Percy, but I guess you're fine with others as well. So I hope I was able to introduce visual testing in a good way. And there's not that much else which is left to say then. Thank you. So if you got questions, please put them here in the chat, or if you come up with them afterwards, you can find me on Twitter or LinkedIn and just shoot it and I'll be happy to answer. And until then, goodbye, and it was wonderful to be here. Oh, sorry.
Hey Roma, thanks a lot for. It's the same every time with the mic. Thanks for your talk. I enjoyed the talk, especially your visuals. Like, I know you draw them yourself, right?
Yeah, exactly.
And what do you use to draw them?
Well, the simple one I do directly in Keynote. But if they're really simple, the more detailed one I use with Procreate on an iPad. So depends on that one, but yeah, it's fun. At first, I actually did it on paper and scanning them, vectorizing them, and editing them. And a talk, I needed like at least a weekend to do a talk. So yeah.
Oh wow! Well, but I love that that you create your own visuals. It's nice. Let's see if there are some questions from the audience. I think so far none, but I have a few. Just let me check here.
Yeah, please shoot.
Yeah. Okay. People ask if sessions will be available later. Yes, just after the talk, the sessions will be available. All right. So I have a few questions.
Please.
So at the beginning you talked about that the main branch is compared with the develop branch or the feature branch or whatever. Mm-hmm. And what happens if the main branch has an error or has a problem? Then it's never going to be detected, right?
Well, not automatically, yes. So this is the reason why I advise you to use a nightly build, which is basically executed on a nightly basis. I would use the night because in this case you don't need to mind about the execution times. So it's monitored on a steady basis, and then there will be some notification if something's merged accidentally or something like this.
Okay, yeah. And also you talked slightly about, and I'm not sure if I understood it correctly, when you have like websites, like single page applications, where the DOM is basically a div that's called app. And like, how does it deal with when everything is loaded onto the DOM afterwards and so on? You said, if I understood correctly, you could wait until the loading is done, until the loading animation, for example, is done. But that would be one. Well, for example, what happens if we don't have a loading animation, for example, if the site just loads, and what would a way be to determine if the site is actually loaded? You said to avoid fixed values, fixed delays.
Mm-hmm. Well, I would try to search for points which happens. Like if it's loading, it's probably a request which is basically being executed. In this case, many testing framework gives you the possibility to wait for those requests. So this is basically my favorite way of waiting in this regard because it's really efficient. If you cannot see a request or a response to wait for, try to find out, okay, what else is visually changing on your page. Mm-hmm. So try to wait for those. Might be maybe a change in classes or change in visuals. Anything you can approach with the assertion of your testing framework. So yeah, in most cases, those two approaches are enough. If not, we need to get a bit more creative.
Okay, yeah, because also some sites have like a an opening animation that it fades in, whatever. I imagine those also give headaches when working with this type of visual testing, right? It's
That's right.
Yeah. Okay. So let me see. Let me see if there's. So if you have any more question, anyone, to Ramona, just put them in the chat, and I will bring it up with her. In the meantime, what else did I have here? Oh yes, how long do visual tests take on larger projects, for example?
Well, I can give some benchmarks of my own experience in my daily doing. They are taking slightly more time than normal E2E tests. So of course it's another command which needs to be executed. On a nightly build, we have I don't have the exact number in my mind yet, but I guess it's around 700 tests, and we are, with parallelization and stuff, we are at 60 to 90 minutes. So depending on the machine they are executed on, I guess we're using AWS workers for it. So so I would calculate with these numbers. But for example, for merge requests, we can limit the test cases being executed. So it's not every test on every pull request, but yeah, maybe only on nightly build when it comes to the complete test route.
All right, thanks, Ramona. We have a question here from
Please.
Alvaro. What's the name of the penguin on the back? I love it, he says.
Oh, it's a good question. This one, it's not the Linux one, but it's a reference to it. It's by a host named MaxCluster, I think. I will ask him for the name and I will come back to you.
Okay. What do we have here? Question: is approving declining differences integrated into the pipeline, or do you have to run tests locally and update the results in the feature branch?
Well, in both cases, like Visual Regression Tracker and Percy, you needed to go to this service page, which is self-hosted in the Visual Regression Tracker case and the software as a service solution of Percy. In the pipeline logs, you can find the link, or you could integrate it as an external job in your pipeline, but you still need to open their page to approve it. But you don't need to do it locally.
Okay, nice. Someone else asked, would you recommend Selenium for end-to-end testing? I don't know what Selenium is.
I actually started with Selenium, and in this time I had some struggles with it because of the way they wait for elements. It's not that dynamic as I wanted it to be. It might have changed in the meantime, hopefully. So if you need to search for a good tool to build the end-to-end test basis for visual testing, either use Cypress or Playwright, in my opinion. But I don't have a good memory of Selenium, but I don't want to say it's bad or something. It might improve in the meantime, so I didn't work with it, I guess, since 2 years or something.
Okay, we have another question. How about scaling? If the tests at many, do you have any preferences, please? Oh, hold on, I might have read it wrong. How about scaling if the testing at many, do you? Okay, I don't really understand the question.
I can imagine it's like, how do I approach testing at scale so that the execution times maybe are not too high? Well, running all tests on a nightly basis where you don't need to take care of the execution times. So if you're sleeping, who cares, basically. Using parallelization. So ideally use a load balancer, but there are other ways as well. And for the actual merge requests or pull requests you're using, decide for a basic test case range. So only the most important stuff should be executed on the single merge request, in my opinion. and be really mindful when it comes to decide, do I really need to write an E2E test for it, or is a unit test enough?
Okay. Nice. Oh, we have someone asking also the same question about that Selenium about Playwright, if you would recommend Playwright for end-to-end testing.
Yeah, basically Cypress and Playwright are my two favorite ones. And then it's up to you what you prefer most. Like if you go for a higher developer experience and the test runner, choose Cypress. And if you have a more developer focused team and not that many testers writing tests, maybe it's a good idea to use Playwright. So case to case, but one of the two you are, I guess, good to go.
Okay, nice. We have another question from Alvaro. Sometimes tests can become really spaghetti code. Which are the recommendations to reuse and organize tests? Oh, this is a good one.
Oh yeah, there are a couple of approaches, and I sometimes reflect on my opinions on this one as well. But still, I think that the main priority for me is that it's easy to maintain your test, and it's easy to still understand your test even in 1 year in the future. So if you use too much abstractions or take too much care about avoiding duplicates, and as a result cannot read your test easily anymore and cannot get your test at the first view on it, maybe it's better to keep a bit duplication in it, even if it's not completely clean codish. But if you want to use abstractions to have a clearer structure, be mindful when it comes to the naming of your helpers or commands. So you can basically see at the first sight what your command or helper or page object or whatever you want to use for splitting, what does it do? Consider using TypeScript to have a better experience as well. And then, so you don't need to think about your tests too much. Like they shouldn't eat up any headspace while you're developing.
Okay, nice. Oh, this is another good one. Good question from Lawrence. For visual testing, is cross-browser testing necessary?
I guess this is a bit opinionated, but I think it's not. So you should be mindful of your resources, especially if you're using a software as a service plan as per se, so you don't get into screenshot limits. If you have an application which is having bigger differences in between, maybe devices or browsers, you can of course consider it. But in let's call it practical experience, it's completely enough to have one mobile viewport, one desktop viewport, maybe one tablet one, and that's okay.
Okay.
So apart from that, there wasn't that much of added value, at least for me.
Yeah, I think there are very marginal cases where this could be an issue, but okay. Oh, Fabian asks, do you use visual regression testing only for scenarios, path, pages, or also single components? Why not?
Well, the typical use case is using visual testing and smoke tests. So you basically run really quickly through your pages, through your components, and make screenshots on certain points. So you can cover much without many execution time. So this is my perfect example. But if I have a component which is really important for me and maybe does some more stuff than just displaying stuff, so it shouldn't be the case, but if there's some logic inside of it, it might be interesting to run visual tests on a component basis as well. But I rarely do it because, most logic shouldn't be in the front end, I think.
Okay. There are, for the moment, no other questions, but I have a question. You seem very passionate about testing. How did you get into testing? What is a little bit your journey towards that?
Ooh, this is an interesting one. So I started as a developer and then get into testing because I have a background in psychology, and I was fascinated on how people interact with software in various ways, and not only the front end point of view, but also the quality point of view. And I think combining those two views on an application is really valuable for both professions, may it be a developer or a tester. And I got back into front-end development again. So it's still, for other reasons, a bit more my passion. But I think it was a good journey. And it's one of the areas where you get close to the way of human interaction in a really specific way. And I think that's fascinating.
All right. Thanks, Ramona. That's a nice insight. We have one more question from Lawrence. How about reporting test results? Please, some hints. I suppose they mean how are they reported to the dev team?
Yeah, so in our case, we rely on Slack notifications. And I guess at least the quality assurance team, we have a cross-functional team. So we have one quality assurance engineer in each team, but they have a team as well, so like a chapter. And they have a regular meeting on, I guess it's a weekly basis, or I'm not sure if it's even on a daily basis, where they screen the main branch ones, basically. But for the pull request, we use Slack notifications to directly ping the developer if there's something wrong.
Okay, nice. Thanks. All right. I think we are ready to wrap this up. Thanks a lot, Ramona. And are you going to be at Vue.js Amsterdam next week?
Yes. So we maybe see each other.
Yes, then I meet you there, and have a great time until then. Bye-bye.
Likewise. See you then.
Bye. All right. So I think we are going to put in a small pause. I read in the chat that some people didn't have enough time to warm up their tea or their kettle for the tea. So we are going to take a short break until we continue with Marcus Oberliner in a few minutes. See you then.
One of the best events, or if not the best event.
Welcome back here at WeAreDevelopers Vue Day. Our next talk is by Marcus Oberlehner. He is software architect at Karriere.at. He's passionate about open source, and he's also today going to talk about testing because he's a test-driven development enthusiast. Welcome to the stage, Marcus.
Hello, Mark. Nice to talk to you again.
Nice talking to you again, Marcus. How have you been these days?
Oh, fine. The weather is not so great in Vienna, but otherwise it's okay. How are you?
Yeah, I'm perfect. Thank you. So you are going to talk about test-driven development today. Can you talk us through a little bit? What are we to expect from your session? What are people going to learn?
What to expect? So what I hope for is that at least some of you after the talk will start writing more tests and writing better tests. And what we will learn is, first of all, how we can optimize our test setup, basically, or how can we, or what principles we have to follow to write good or better tests.
Okay, nice. That sounds interesting. So without any further ado, take it away, Marcus.
Thank you, Marc. So Ramona already did a great job talking about testing and hyping the topic a little bit up, I think. So it's great to follow her. Today I want to talk about test-driven development for Vue developers. And I want to start with a short story. A couple of years ago, my colleagues and I, we were tasked to create a completely new project from scratch, and we were very thrilled about it because we were a team of very motivated and talented developers. And so we wanted to do everything the right way. And for us, the right way also meant that we wanted to do testing, or that we even want to do test-driven development. So we wrote a lot of tests. We wrote end-to-end tests, we wrote unit tests, and we also wrote a lot of component tests for our Vue application. And time passed, and the project worked perfectly out, and everybody lived happily ever after. As you might already thought, or as you might already know from your own experience, that's unfortunately not how most of the time software development projects go, and it wasn't for ours as well. So although we wrote a lot of tests, I was not very experienced at the time with writing tests and didn't know about the best practices we needed to follow to write good tests. So we ended up writing a lot of bad tests, which at the end of the day not even didn't help us much, but also sometimes hindered us in our progress. And today I want to show you what I've learned during the years since then and how I think we all can write better tests. So let's start. First of all, why should we even care about writing tests? So Ramona already took a couple of things away, but I think that one of the most important parts when it comes to working in a test-driven way is that with good tests, we can refactor our code with confidence. So whenever we make some change somewhere in our code base and we are not quite sure if what we change has some effect on some other part of our code or our application, then if we have good tests in place, then we are able to make this change. And if our tests still pass, we are relatively confident that everything still works as expected. Or even if our tests don't pass, then we know, we have to look somewhere else. And if we have very good tests in place, they should even tell us where to look for the problem we caused, we didn't expect to cause. So the first part of writing good tests is it enables us to refactor our code whenever we want with confidence. The second aspect is that writing tests and working in a test-driven way and writing good tests enables us to write better code faster. And there are two ways in which testing can help us achieve this. First of all, with automated tests, we get fast feedback loops. So we write the test for our code, then we write some code, and immediately after we wrote the code, a couple of seconds later, the test tells us if the code we wrote actually does what we expect it to do or not. And if it does not what we expected it to do, then we can work on the code again and change the code and save again, and the test runs again, and a couple of milliseconds later, again, we know if everything works as expected or not. So we get faster feedback loops, which enables us to write code faster. But as for the first factor, as for refactoring, when we are able to refactor our code whenever we want, we are able to improve our code. And enables us to write better code. And last but not least, if you have good tests in place, you can even deploy on Friday, but you don't have to if you really don't want to. Okay, so I said the phrase good tests a couple of times, what good tests enable us to do. But now I'm sure you wonder, how do we write good tests? Unfortunately, there are only two major principles we have to follow. The first one being write tests first. So if we want to avoid writing bad tests, and bad tests are mostly tests that are coupled to implementation details, for example, or tests that are slow and stuff like that, or very complicated. If you want to avoid writing bad tests, one of the safest way to do this is to write the test first before you write any implementation code. So we have a feature in mind, and we know about the specifications of this feature, so we can write an automated test which makes sure that all those specifications are met, and then only then we start writing code. That way, that's probably the most important way of how we can avoid writing bad tests. All right, and so write good tests instead. And the second major principle is to decouple all the things. What do I mean by all the things? We will look at that. As with coding, where it's also important to decouple certain parts. So for example, you want to decouple your database logic from your business logic and stuff like that to write better code. And it's the same for testing to some degree. So the first aspect of how we can decouple our tests, or what we need to decouple our tests from, is from the test framework. For example, if you use Cypress, for example, then you are locked into one test framework. And that's a problem, because the first reason why we want to decouple our tests from a test framework is for risk management. We want to reduce risk, and we want to reduce the cost of change. So imagine some test framework vendor decides that they don't want to maintain the test framework anymore, or even they decide to release a new version with a lot of breaking changes. If your tests are very tightly coupled to the single test framework, then whenever this happens, you either have to rewrite all of your tests to use a new maintained framework, or you need to fix all the breaking changes, for example. So you have a very high cost of change in this case. And the second reason why it makes a lot of sense, in my opinion, to at least decouple your end-to-end tests from a particular test framework is to use, or it enables you to use the best tool for the use case you have. So imagine you're making a quick change and you want to quickly know if you broke something or everything probably still works. In this case, it's very important to you that you get very, very fast feedback. But then there's also the case where you want to know if your tests run in a real browser, if everything works in Chrome, for example. Then speed is not the most important factor, but you want to be sure that it works in a real browser. And then if you have decoupled your tests from the test framework, you're able to run your tests in either, for example, VTest if you want to have very fast feedback, or in Cypress if you want to benefit from the great user interface of Cypress. So, let's stick with this slide and give you a quick demo about how this looks. So if you look at the right, then here we have a couple of tests in this repository, and with npx vtest run, we can run all those tests in vtest, and we see we have like 5 tests, and they all passed successfully very quickly. So we get very quick feedback, and it's even quick, even if we have hundreds of tests. But now, thanks to decoupling of the tests, what we are able to do is, here you see the same tests that we just run in vtest. We can also run them in Cypress, for example. They are also very fast because they are only 2 for now. But if you have hundreds of tests, then Cypress will be slower, but you get the nice user interface you see here. So with Cypress, it's very easy to debug stuff because you can see what is happening. You can see here it visits the page, and then it finds some text, and then it clicks, for example, in this case. So it's easy for debugging, and whenever you need the nice user interface, or whenever you need to know if your application actually works in a real browser. So we will see a couple of tests now on the following slides, and I want to show you what we are testing. Here you see a very simple shopping list application. It's basically a to-do list application, but especially for shopping. So we could add some milk to our shopping list. And at the end, we want to also be able to remove stuff from the shopping list. So imagine you are in the shop, and you put the bread in your bag, and then you want to cross out the bread, basically, or click on the bread, and so it's removed from the active items of your shopping list. But we will implement this feature later. For now, we only have the feature of adding new items. Okay, so decoupling from the test framework reduces risk, because we are able to switch test frameworks if we need to, if we want to use a new and shiny test framework, or if we have to because some framework is not maintained anymore. And it also enables us to use a fast framework like vtest if we want to have very fast feedback, or a framework like Cypress if we want to have the benefits of the UI. And how can we do this? So here we see a test. Here we see the test for adding a new item to the shopping list written in Cypress. So this test is tightly coupled to Cypress. You can see here we use the Cypress object, and then we use methods like visit on the Cypress object, to get some element and type something, again to get some element and click on it, and last but not least, also get an element, and we check if the element exists. So this is the test for testing. If we can enter something in this input field, click the Add Item button, and then check if it was added to our shopping list. So how can we decouple this, or how would it look like if we would decouple this test from Cypress and make it generic so we can run it in every test framework we want? So what you see here is, now instead of using the Cypress object directly, we inject a driver. And now this driver is basically a generic interface. So we can inject whatever driver we want. We can inject a vtest driver, we can inject a playwright driver, and we can also inject a Cypress driver. But other than that, for now, I stuck with the API of Cypress, basically. So instead of Cypress, we're now using the driver, the generic driver, which now can be Cypress or vtest or playwright or whatever. And we can use Cypress visit to open the page, again, get some item, type something in, get the button and click it, and get some item and check if it exists. So nothing really changed, but now we are injecting the driver, and therefore we are able to inject whatever driver we want. And when we want to swap a test framework, we just need to implement a new driver, which you can do in like 100 lines of code or something like that. Maybe if we have some time later, we can take a closer look at the driver implementation. So this is an end-to-end test, or I want to call them application tests. So this is a test testing your whole application. But how does this look like for component tests? And here we see a component test, so for a single Vue component. And for component tests, in my opinion, this is not that important. So I still prefer to have some kind of decoupling from the framework, also with component tests. So here we see, instead of importing the test methods from for example, from Vue test utils and from vtest, I import them from a utils file. So that way, there are a couple of benefits. First of all, I can import all the stuff from a single utils file. Otherwise, I would need to import the mount function, for example, from Vue test utils and expect and it from vtest. That way, I can import all of them from one file. And second, you can imagine that I could swap, for example, vtest for jest very easily, because instead of re-exporting expect and it from vtest, I could re-export it from jest, and it would probably work the same. And again, I only have to change stuff in one place and not in every test. But this level of abstraction is somewhat leaky, but I think it's okay for component tests, because it's more important for end-to-end tests, because for end-to-end tests or application tests, the differences between test frameworks are much bigger than with component tests. So this was the first aspect from about decoupling from our tests from the test framework for reducing risk and reducing cost of change, and also being able to use the best tool for the job. So either the fastest tool or the tool with the best user interface whenever we need either one. The second aspect when it comes to decoupling is we want to decouple our tests from implementation details. So this is probably the most important thing you have to consider when you write tests, when you want to write good tests, is you don't want to couple your tests to implementation details of your code. So how can we do this? Let's start with an end-to-end test again. So here we see the same test from before, now with the driver, but we can see that this end-to-end test is coupled to implementation details of the application, especially via CSS selectors. So here we see we use the item input CSS selector for selecting the input field. And we are also using a CSS selector, the add item button CSS selector, for selecting the button that we want to click when we add an item. And also for the assertion, we also rely on a CSS selector. And this is a problem because CSS selectors are not meant as hooks for your tests. So CSS selectors are meant for styling. So we don't want to use them in our tests. We don't want to rely on something that's meant for styling to test our application, because whenever some developer changes the selector, this test and maybe a couple of other tests break. So whenever a selector is changed because we need to make changes to the styling, then we also need to change a lot of tests. And not only is this annoying to do, but it's also somewhat confusing. Or when you look at the merge request, you see, oh, a couple of tests were changed. Why needed tests to be changed when the color of a button was changed? It just doesn't make sense. So you want to decouple your end-to-end tests, for example, from implementation details like CSS classes. And the best way to do this is to use semantic selector methods. And here we can see we swapped the selector method. So instead of using a generic get selector method to get some HTML element by a selector, by a class selector, for example, we can use the semantic find by label text selector for finding an input field with a certain label. In this case, finding an input field with the label title, for example. So imagine looking at your application like a real user would do. So a real user would look at the shopping list application and would wonder, where is some input field where I can enter my item I want to add to the shopping list. So they are looking for some field with a certain label, which to them signals that this is the right field to enter their shopping list item. So using find by label text somehow mirrors what a real user would do. And it's the same for the next one, for the find by role one. So the next step after entering some text in this input field is to submit the text, and therefore we want to look for a button, for example. So we want to look for an element with a certain role, in this case with the role of a button, which has a certain name, in this case add item, and then we want to click it. And the nice thing about this find by role method, and also about the find by label text method, is that it forces us to do the right thing for our markup. So in the markup, we want to use labels, so our markup is accessible. We want to use buttons for clickable elements, so our markup is accessible. So by using those semantic selectors, or those semantic methods, selector methods, we also ensure that our application is more accessible at the end of the day. And we test this with our tests as well, as a side effect, not even by design. Last but not least, again, a user who enters a new shopping list item expects to see this text of the new item somewhere on the page, and we do the same here in our test. We find an element by text, in this case bread, because above we entered bread, and we make sure it exists. So much for decoupling our end-to-end tests from one particular implementation detail, CSS classes. But it's even more importantly, so decoupling our tests from implementation details is even more important when it comes to component tests. And here we see the component test from before again, and there is one aspect where we have coupled this component test to an implementation detail of the component. And it's here by triggering a delete method on the Vue component object. And this is a big anti-pattern when it comes to component testing. Fortunately, that's not that easy to do anymore with Vue 3. So Vue 3 kind of forces us to, or at least if we are using Vue 3 with the script setup, which basically is the default by now. So, but still, there are other ways we can test implementation details in components. For example, when we test a computed property directly, or maybe even override the computed property, or if we override a prop in the test and stuff like that. So there are a number of ways how we can test or change implementation details, and we should absolutely not do this in component tests. But how can we avoid it? In this, so it always depends what implementation detail we want to avoid. But in the case of a method, for example, of this delete method, we could imagine rewriting the test like this. So again, we use semantic selectors, and we get them from a tool called testing library. And I highly recommend to check out the testing library because it's really, really good and enables you to write, or it makes it very hard to write bad tests actually. And this testing library gives us a screen object and a user event object. And also we change the text. So in the previous test, the text was that the test description was it should emit a delete event when executing the delete method. And here we change the text to it should emit a delete event when clicking the delete button. So we want to interact in our test, we want to interact with the component like a real user would do, not by accessing private methods of the component itself. And after we've changed the text, we can simulate a user by creating a new user object with this user event setup method that comes from the testing library. And then we can simulate the click. And as we already saw with the end-to-end test, we now have this find by role selector method. And again, we find a button by role, in this case, one with the name delete. And we click this button, and then we expect that the correct event was emitted. And by that, we have decoupled the component test from implementation details. In this case, from the implementation detail that the component has a particular method. And the biggest benefit what this gives us is that we can freely refactor our component. So if we go back to the bad test where we have this delete method, now if we decide to completely change the implementation of our component, so we don't have a delete method anymore because we decide we want to call it remove, or maybe we build it completely differently and we don't even have a separate method anymore, but we directly emit an event in the event handler because, yeah, whatever. We simply decide we want to completely refactor it. In this case, if we are coupled to implementation details, then our test will break, although the functionality didn't really break. And that's exactly what should not happen. So our test should enable us to freely refactor our code and then give us the confidence that we didn't break anything. It's the same as Ramona told us with her story about the boy who called Wolf. When your tests fail every time you refactor something, although your functionality didn't break, then you don't trust at some point you don't trust your tests anymore, or you think that they are not very useful, because in this case they aren't. But if you decouple your tests from those implementation details, you can refactor freely, and the tests will only cry wolf if you actually broke something that is important. Okay, so much for decoupling. Most important for unit tests and component tests, but also important for your end-to-end tests and application tests. The last thing when it comes to decoupling that you have to consider for writing good tests is that you should think about decoupling your tests from the user interface. So this might sound a little bit abstract at first, because the user, how could we even decouple our tests from the user interface? The user interface is such an important part of our front-end application, right? So it's basically what we are building. But it makes a lot of sense to do it, and I will show you how we can do it. So here we see the test from before again, the end-to-end test, and we see this test is coupled to the user interface in a couple of ways. First, it starts with the visit and then some path command here, because that an application has, or that there is a concept of paths is basically only true for web applications. So if you think about something like a mobile application or even a native desktop application, there are no paths. So this is an implementation detail that comes from the fact that we are building a web application. And here is the same for this find by label text. So although this is semantically correct and nice, but I hope you can't hear this. It's very loud around here. But anyway, because here we are checking if there is an input field. And again, the fact that there is an input field is again a property of a web application or of a computer application with a particular interface. You could imagine having an interface where you talk to your computer, like I can't say it right now because otherwise it will start, but or I can say Amazon Echo because I have the other one. So if you say the command, for example, if for applications like that, then there you have no input field. And it's the same with a button. So in situations like that, you don't have a button. But now you might wonder, yeah, why should you worry about this? Because after all, we are building a web application and we probably won't ever rebuild it to be like an Amazon Echo plugin or something like that. And you're probably right with this assertion, but why it still matters to decouple or why it still can make a lot of sense to decouple your application from the user interface is because when we take a look at a refactored test or at the same test which we refactored to be decoupled, then here we have, for example, a shopping list open method. And this is something everybody can understand. So even a domain expert in the realm of shopping lists, which probably is everybody of us to some degree, knows what it means to open a shopping list. You can imagine having a physical shopping list in front of you, and you can open it if it's some kind of notebook or something like that. The same with add item. So add item is true regardless if you have a physical notebook in front of you where you add a new item to the shopping list, or if you have some voice command tool. In each case, you can add items. And that's also true for the assertion. So we expect that if we've added an item, we expect that there is some item on this list. And this is a very simple test, but imagine you have a more complicated problem domain. You have like accounting or something like that. So in case you want to talk to a domain expert about this, then a domain expert can look at this, or your PO, for example, people who are not that technical, but have a lot of knowledge about the domain you are working on, hopefully. Those people can understand this test. It makes sense to them. It makes sense to them to open a shopping list. It makes sense to add an item to the shopping list. And it makes sense that if we've added the item to the shopping list, that we expect it to be there. And if you imagine more complicated cases, like I said, about accounting and stuff like that, you can show your tests to your domain experts and ask them if you understood this correctly, if this test is saying what it is expected, or if this is showing the expected behavior of your application. And this can be very, very valuable. And also, it was also at the end in one of the questions to Ramona about abstraction. And Ramona, rightfully so, said that we have to be careful with abstraction. But if we look at the implementation of those generic or of those add item methods we saw in the test, then this can be one layer, one very tiny layer of abstraction that makes it easy to reuse certain test methods. For example, if you're building a shopping list application, you probably have a lot of tests where you need to add items. And here we see the add item step are actually two steps, like find by label text and find by role. And thanks to that, we can save, or we have fewer lines. So every time we need, in a test, we need to add an item, we can just trigger this one method. And it makes a lot of sense to read this test, and it also dries up our test a little bit without making it more complicated, which we have to be careful about, obviously. And what we call this pattern is a domain-specific language. So you can see here DSL in short, and you can, in your tests, or basically when you're working on a big project, it's a good practice to come up with a domain model. And in your domain model, you specify certain words or for entities, and you also have your own grammar, for example. So you say in our shopping list problem domain, always when we add an item to the shopping list, we're talking about adding items. It's not about creating items. No, our DSL says when we add a new item, it's called add item. And so we have formalized our domain language in our tests. So we have our own domain-specific language for our tests too. So everybody who looks at this, who is familiar with this domain language, with this domain model of your application, also knows what we are talking about in the tests, which is a very nice thing, especially if we talk about very large applications, which live for years. Okay, so this was the first principle that we talked about of the two. So at the beginning, I said there are two principles for writing good tests. The second, or this was basically the second one. The second one is decouple all the things. Decouple your tests from the framework, decouple your tests from implementation details, and decouple your tests even from the user interface, at least if it makes sense in the context of your application. But the most important principle is that we write tests, or we maybe should even say specifications first. So why did I cross out tests here? If you think about it, a test basically implies that there is something and we test if it fulfills whatever we expect it to fulfill. But with a specification, the semantics are slightly different. A specification we usually come up before we produce something, be it a physical product or some code. So I want you to think about more about specifications than about tests. So we want to write specifications. We want to write them before we write code, and we want to automatically make sure that whatever we specified is met by the code we write, the applications we build. So why want we, or what are the benefits of writing tests first? So the major benefit, I think, is that it forces us to think about the public API of our code first. So imagine we are creating a new component, and if we write the test for the component first, the first thing we think about are the props we pass into the component and probably even the events that are emitted by the component. Opposed to starting writing code for the component directly, then we are not so much concerned about those things from the perspective of somebody using the component, but from somebody who is just building the component. But a test basically means we are also users of our component, because in our test, we use the component to make sure that it does what it does. And that way, we are usually able to come up with better public APIs for our code. So how we name our properties and how we name events and in which format we emit data through events and stuff like that. And again, writing tests first also enables us to get faster feedback. So the feedback loops are much faster if we have an automated test in place from the beginning. Because think about it, you have to test your code anyway. You have to test your application anyway. It's only the question if you do it manually, like write some code for a component, open your browser, click through the component manually, make sure if it does what it should do, if not, go back to the code and so on. Or if this is done automatically for us. So if you write the specification first, you don't have to do this manually, but you have the test which automatically and very fast, much faster than you can do it, clicks through your component and makes sure the code you just wrote hopefully works correctly, or if not, you get very fast feedback that it doesn't work correctly yet, and you can focus on writing code instead of switching to the browser again and again and testing manually. And ultimately, what this all leads to is that we are able to come up with a better design for our application. Because as I said already at the beginning, if we get fast feedback, if we can refactor our code whenever we want, and if we are forced to think about the public API first, then usually we end up with a better API or with a better design for our whole architecture and all components of our code. So, now comes the live coding part, where we can look at how we actually can write tests first, how we are able to do this. And for this, I open my editor real quick, and also I start the tests here. Oh, like that. So our tests are running, and they will rerun whenever I save the file here. Now they are passing because we didn't write the test yet. So let's write a new application or end-to-end test. So we want what I told you before. We want to be able to not only add new items, but now we also want to be able to click on here to remove the item as well. So let's do this. So we want to have, it should be possible to remove an item like that. So again, we open the shopping list, but now to be able to remove an item, there should be items on the list to begin with. So we add this precondition here. For this, we need to inject the driver as well. So this precondition, this precondition basically makes sure that in our local storage, there are already two items to render in our application. So we prepare this here. Then we open the application. So we go to the home page. We don't need to add an item here, but we want to remove an item. And yeah, we can remove the bread item. And you can see here this remove item. We've already got this in our DSL shopping list object. We have this remove item function where we click on the button with the given title. So in this case, for example, if we would say we want to remove item milk, we would click on here. So we want to remove an item, and then we expect item not on list bread, because after we've removed it, we expect it to be not on the list anymore. So now we can save this one and take a look at our tests, and we now see a failing test because we didn't implement the functionality yet. And just like that, we now could move on to writing the implementation code, but I want to add another test. I think it makes sense to add a component test now as well, because when we look at our application component, then we see here, we have the shopping list application or shopping list app component in which we render a child component, the shopping list component. And this shopping list component is responsible for rendering the list of items. So here, if I add bread, also this list of items is rendered by this shopping list component. But the data handling happens in the shopping list app component. So we can see here in this shopping list app component, we have this add item component, and we have all the logic for rendering active item or for finding the active items and stuff like that. So the shopping list child component and the app component need to communicate. And whenever components need to communicate with each other, that's probably a good place or a good reason to write a component test. And to save some time, I've already prepared the component test in here. So I only have to comment it out, but I will explain to you. So in this component test for a shopping list component, we want, or we say it should emit and remove event when we click an item. So when we click here, this list component should emit an event, because we need to communicate with the parent component and tell it that the item was clicked. So the parent component can react to it and handle the data accordingly. So as we already saw in the presentation, we now can use the testing library to create a new user object and use it later to click something. But first we need to render our shopping list component that we want to test, and we render it with some props. So with the items, we want to start with one item in the shopping list so we can click it and see if the correct event was emitted. And here we click the button with the name bread. So this is the item, for example, this item that we want to click on. And then with this emitted helper function, we want to make sure that a name called remove is emitted once. So the first array item means this is the, if we would emit remove multiple times, we would have indices null to 10 if we would emit, or if we would click 10 times, for example. And the second one is the param. So I will show you this when we write the code. So, and here we expect to emit the ID. And this is already the first decision we make from the perspective of a user of the component, of some developer who uses the component, because we now can think about, do we want maybe the title of the shopping list item? Do we want the ID of the shopping list item? Or maybe do we even want to have the whole object? So this is a decision we now make from the perspective of somebody using this component. In this case, I have decided I want to have the ID. I want to emit the ID of the component. So if we save this as well and take a look at our tests, we see, we should see 2 failing tests. There's still only one. Not quite sure why. Let's start again. Now there are 2 failing tests. Nice. So the first one is the end-to-end test, and the second one is this component test. So now let's fix the component test or implement the functionality for the component test. And if we look at why it fails, it tells us, so we have to scroll a little bit. I can find it, but it tells us as the first, here, it's right there. It tells us that it can't find a button element. So because this is a diff for now, because for now it was not clickable and it made sense that it's a diff, but now it should be clickable. So let's make it a button, like this. And now it still fails, but not anymore because it can't find a button, but now it fails because there is no remove event emitted. So we change this. We add an event handler, a click handler, and say emit and remove. And if I would save this, then it would still complain because we don't. So now it gets the ID, but it don't gets the. Now it gets the event, but not the correct ID. And here we see the first param should be the item ID. And if we would add more params here, then those would be in array index 1, 2, 3, and so on. So, but now if we save this, now we should only have 1 failing test because the component test now succeeds. So we tested our component, the behavior of our component successfully, but the feature still doesn't work because we didn't implement the functionality in this shopping list app component. So if you remember, we want to be able to remove an item from the list, and this we are testing with this test view. So we now know this shopping list component emits a remove event. And because we already have here an add item method, we probably will call it remove item. And as a starting point, we can even copy the add item method, rename it to remove item. We get the ID as a param for the event. So we can say here item ID, it's a number. We get the item ID here as the first param. And the repository methods are the shopping list repository we use here for create and get list methods also has an update method we can use here. So here we have the update method. Let's take a look at the signature of this method. It's like ID and then the state we want to set. So we can say here item ID. And we want to deactivate the item. So we say state inactive. Thanks to TypeScript, we get the type hints as well. And after we've updated the item in the local storage, we want to update the items that we render as well. So we use the get list methods to get all the shopping list items from with the updated item from the local storage. We can remove this one here and save it again. And now our test passes. So we didn't even, we implemented a new feature and we didn't even need to look once in the browser. But we always got very fast feedback in milliseconds whether our code worked correctly or not. But if you don't believe me that this actually works, let's open the browser and now click here, works, click here, works. So now we are able to remove items as well. And we did this in a test-driven way. So now our application is perfectly tested with tests that everybody can understand because we decoupled them from the user interface, for example. And we are good to go and build new features or refactor our code. So in a traditional test-driven development cycle, you would now look for ways how you can improve the code. But this was a very simple example. So I think it should be fine like that. So just like that, we have learned 2 things. First of all, decouple all the things, write tests or specifications first. And if you do all this, enjoy your work. Thank you. I can't hear you.
Oh, thanks for your talk. Same thing again. I must say, the last 10 minutes, I didn't really watch it because suddenly my screen was completely off, no audio, failure of my docking station.
Oh no.
So
That's
yeah,
unfortunate.
but I'm back right in time for this. So yeah, these were great insights. I always love talks about testing. People are like, oh yeah, now we need to do testing. We need to do testing. But then you get to your boss or whoever, project manager, and then you are like, hey, what about test-driven development? And then they say something about, it's so much overhead. We need features, or how do you tackle those type of arguments? Because I worked in a company that didn't have any tests, and they didn't want to invest time and money into tests. And how, as an engineer, do I convince people that we need tests?
Oh, I have a couple of things to say about that. So, first of all, to be very bold, basically don't talk to managers about this. So consider it as something that's part of your job. So you want to write quality code. Hopefully your managers want you to write high quality code, and this is one aspect of writing high quality code. They probably don't have much to say about other aspects of your tech stack as well. So that's the bold statement. But I know that's in reality it's probably not that realistic. But then the second argument, which basically which I think is better suited for management, is like, think about it as you have there is a graphic where you can see the cost of change over time for a software project. And usually this graphic shows like up. So like we start with very little cost. When we have very little code, then making changes is easy, and writing new features is easy, and everything is awesome, you know. But typically where we end up is like at the top somewhere, where making changes is very hard, and every time we make a new change, we introduce new bugs, and writing new features is also very daunting because everything is complicated and tangled mess and so on. And I can't say that testing, like I said at the beginning, when you can also with tests end up in a situation like that. But that's what my talk was aimed at. If you have the right kinds of tests, and if you follow some best practices, then I think testing is an awesome way to keep this cost of change line flat. So you start with very minimal cost of change, and in a perfect world, maybe it goes even down, but at least it stays like at a certain level. So I think this is the answer that's probably more suited for the realities of most of us. But also, still, I would say don't talk too much about management, about testing.
All right, so thanks. And we have a few questions from the audience. Anyone else in the audience who still has questions for Marcus, please put them in the chat and I will bring them up. All right, we have Fabian asking 2 questions. The first one is, when decoupling from implementation, how do you deal with component logic depending on a global state or APIs?
That's a great point, because that's basically one aspect why writing tests first is so important. Because if you don't write your tests first, it will be very easy to build components that rely on global state and other stuff. But if you write your tests first, it will be much harder. So you will build less components that depend on global state, which probably is a good practice to follow. But if you are already in the situation that you have components dealing with global state, then yeah, to be honest, it gets tricky there. But then I would probably follow some way where you always initialize, for example, a global bin store by default with every test, so you don't have to think about it. So you always have the default global store or global state or whatever it is initialized with a test, so you don't have to do a lot of setup work for every test, because that's something we ran into with our application, that we had to do a lot of work for every unit test to set up all the global state specifics, and then it gets really complicated.
Yeah, makes sense. The second question from Fabian is, when decoupling drivers, user interfaces, and domain-specific language, there are multiple layers of abstraction, adapters, and so on. How do you organize these in your file structure?
Yeah, I can show you this if you show my screen again. Then we can take a look. So here there is the test directory in the root directory of my project, and there is a drivers folder, and in here there are the drivers for all the frameworks I want to use. So I only showed you VTest and Cypress, but you can run the same tests in Playwright as well. And I have the specifications in this project. The specifications are also at the test level. So those are the end-to-end tests. In a big application, you probably want to split them by domain or something like that. You have to find some way how you split them. But that's basically, so I keep the specifications for the end-to-end or application tests outside of the source directory. But inside of the source directory, I have the, let me see, or I can't show you in here, but because here I put the DSL directly in the test, but in a real application, in a bigger application, I probably would split up my source directory into domains. So imagine e-commerce application, you could have a domain for the checkout and another domain for shipping and stuff like that. So you probably have a shipping directory in here and also a checkout directory. And then I would put like folders like that in those domain folders, and in there would be the domain-specific language for each domain package. That's the way I would go.
Okay, nice.
But it depends on the complexity of your application, of course. So if you have a simple application, I would keep the directory structure as flat as possible.
Okay, yeah, that makes sense. So yeah, I have a few more questions from my own. One is, you showed the domain-specific tests where it's like very like add item to shopping list bread and so on. Are there maybe tools that transform this code into even more human readable things, that it's not even code you show your domain experts, but a real, just like a list of text?
So there is a real domain-specific language called Gherkin, where you can use basically sentence. This is maybe some of you have already seen it. It's like you have sentence starting with given, when, then. So you always have this 3-layer structure: given, some state, when I do something, then I expect something. And you can write this in natural language, but then you have this translation layer again, and you have abstraction over abstraction. And we actually did this for our application. We used Gherkin, and we found that this is too much. So it's simpler to have only the code layer, but you can do it. And maybe with AI and stuff like that, maybe that becomes interesting again.
Okay, nice. And yeah, you maybe have showed this just when my screen went out, but I will ask it anyways. Do we start with failing tests?
Yeah.
Or
we always
failing tests,
exactly.
right?
We always start with failing tests.
Okay, nice. Okay, I think that's all the questions from me. Let me just check. There's no more answers from the audience. Last chance. Anyone from the audience? Questions for Marcus? 3, 2, 1. No. Okay. Then thanks a lot for your talk. As
Thank you for
always,
having
very
me.
inspirational. And I will see you as well next week in Amsterdam.
Yeah, I'm looking forward to it.
Yes. Cool. Then have a great rest of your week and see you then.
Thank you. Thank you. See
Okay.
you.
See you. All right. Before I announce our next speaker, I have a few announcements. One is to remind you that in July we have our World Congress with many great speakers, with over 10,000 attendees, a lot of very interesting topics that you can listen to, and many interesting people you can interact with there. So if you're interested in this for Europe, this is like a really great conference. If you're interested, visit worldcongress.dev. And I want to remind you of our Meta Quest giveaway. So this cool virtual reality thing like this, you can win it. In order to win it, you have to enter the contest hosted by Deloitte. Just go to WeAreDevelopers/live. You scroll down a little bit, and there is an image of the headset, and then you enter the raffle, and then hopefully you win it. All right. Now to our next speaker, Alvaro Saborido. He is DevRel at Storyblock. He is a content creator where he talks often or mostly about Nuxt, and he is learning 3D modeling and WebGL. Welcome, Alvaro.
Hey, thank you, Marc. How's it going?
Hey, ¿cómo estás? How are you doing? Everything good?
All good. Man, you
Nice,
pronounced
nice.
my last name correctly. I'm so glad.
Awesome. Speaking so many years in Spanish has to show for something, right?
Awesome.
All right. So what are you showing us today? TresJS, is this something you wrote in a library you designed?
Correctly. So today is the official announcement of the library that we have been working on privately during December. As you mentioned, I was really into last year for 3D, 3GS, and doing things on the web. And I decided I wanted something for Vue, so I enabled the Vue community to work on 3D experience on their website. So let's see how it goes.
Nice. That sounds super cool. I'm looking forward to your talk. And without further ado, Alvaro, take the stage.
Thank you very much. So first of all, let's confirm that I'm audible. We can see the slides, and I'm going to present a lot of nice demos today. So if in any moment you don't see one of the demos that are inserted into the slide, just let me know, okay? So what if I tell you that this is scene right here that is coming from Bruno Simon's 3GS course called 3GS Journey is done entirely using Vue components. From the portal itself and this nice animation that he has right here with shaders to the fireflies that are floating on the scene. We can even use this interface to change the variables for the color and so on. So that's basically Vue components that forms a 3GS scene. So if you look at the parent component, it will look something like this. So we will have a script set up with, in this case, TypeScript. We're importing some stuff, and we have components for the portal and the Firefly. And then basically we have a template that creates the whole 3D experience. If I show you, for example, the stack blitz, so let me share the other tab. I have the same example here for the Bruno Simon portal, and you can see the portal.vue. It has a lot of code that comes from the packages, and then some shaders, a lot of fancy stuff, composables to import the models, composable to import the textures, everything that you normally do in TresJS is possible by using Tres. So, like 1 year ago, I was really into TresJS and all the fancy stuff that you can build with it in the web. And I found out that there was no way, or it was difficult to create 3D experience using Vue. So you basically needed to use TresJS raw, okay? So like vanilla TresJS to do stuff. And I decided to create a library to create these 3D scenes declaratively. The name of the library is called Tres. It's the Spanish word for three, pronounced tres. And of course, it's a reference to the library, TresJS. But since I'm Latin and the French word was already used by another library, I decided to call it Tres. Also here you can see a really fancy, let's see if it's animated. No, it doesn't seem like animated. Oh no, sorry. I'm sharing the wrong screen. I knew it. Okay, so here is the animation that I wanted to show you. This was done by another member of the community, which is Kisu. He helped me out doing this like Love, Death, and Robots animation. The first time we shared the logo, everyone was like, okay, it looks like the animation from the Netflix series, so that we decided to do something fancy with it. So what's our motivation? As I was mentioning before, TresJS is a library, a JavaScript library that allows you to create a WebGL 3D experience, but it's also a library that is constantly updated. Every day there is a new thing. They launch new versions every time. So it was hard for libraries that already exist for Vue, like TresJS, that are basically wrappers of this TresJS to keep up with the old enhancement, okay? Then I have the sample of the React 3 fiber library, and you will tell me, Alvaro, why are you talking about React in the Vue.js Day conference, right? But I want to express that we can take all the good things that other frameworks have, instead of battling every time multi frameworks and so on, and take the good things from them. So this library is amazing. I tried by doing the Bruno Simon's 3JS Journey course, and I love how you could create these 3D scenes with React components. So I thought to myself, I want the same for Vue. I want to be able to use my favorite framework. So I was searching for something similar in Vue.js ecosystem, and I found something called Launchbox, which is the same concept as React 3 Fiber. It's a custom render. The only problem now is that mixing different renders in Vue 3 is something that the Vue community is still working on. As for now, I don't know if there is it's possible to have a reconciliation layer, such as it's in React, to mix both renderings. So if you are using Launchbox, you will need to create 2 different apps, and this might not be ideal. So I was inspired by these amazing libraries, and also by people in the community, especially the 3D community. So I was talking in Twitter with 0xCA0A. For now, we're going to call it the Hex guy. He's part of this React 3 Fiber. Okay, and we have a nice talk about how we could do that in Vue. And one of the most important thing was make it possible that you generate all the components from the latest TresJS constructors. So you basically have the TresJS with the synth constructor, the new mesh constructor, and transpolate all of that into Vue components. So you have a 0 to none maintenance. So a special mention to him that sparked that creativity. And then we had the challenge. The challenge was to have something that is up to date with TresJS, with low maintenance. Also, something that wouldn't necessarily require a custom render, that is performant even with the reactivity that Vue provides. We're talking about rendering a lot of things in the browser, so it needs to be performant. I want it to be verbose and easy to use, both for 3DS users that want to try it in Vue, as well for Vue developers that want to start doing 3D experience and not have that much experience with 3DS, right? Last but not least, I wanted to form like a 3D ecosystem for the Vue community that allows you to create a 3D experience, and I had plugins for several other fancy stuff, like for example, physics. So how we get started with TresJS? You can install it by using npm, or in this case, I'm putting an example pnpm add TresJS/core, and as a peer dependency, we need to install 3. You can also play with it directly on the link for StackBlitz. You can see the basic demos in the collection there. And something that I want to mention at the beginning is that TresJS is possible and is powered by Vue.js. So Vue has been a really necessary tool for this in terms of the speed, and we will talk about it in a few minutes. So let's talk about how we can start using it, right? We can use it as a plugin. So the way of using it will be importing it from the core package. Then you create your app like normally you will do. And then you do app.use, you pass the Tres plugin, and you can also pass some options, like for example, the prefix for the components. Finally, you mount your app. So in 3D, of course, we're using the browser, right? We're using the DOM. So everything that we create programmatically, we will need to somehow painting it on the browser, right? So the best thing to do that is using a canvas element, or like a DOM element. So the first thing you will need to add to your template is a component called TresCanvas, which is essentially adding a DOM element of canvas. Important to mention, everything, all the components, all the things that you want to add to the scene needs to be inside of this canvas element. Then we will need to set up our scene. So on the left side, you can see like a little diagram that I draw about some of the objects that the 3D experience will need, right? So first of all, we have the objects. We want to show something. It could be a sphere. It could be a light reflecting on that sphere, and then a plane with the shadow that emits from them. Then you will need something to see it. In this case, it's a camera. So the camera is basically taking the 3D scene for a specific angle or a specific perspective and converting it into a 2D space that is going to be rendered on the canvas. Then you need a scene that will pull everything together and a renderer to render it into the canvas. I know it's rendering, but we are going to do that a lot. So if we were using plain 3DS, you will need to do something like this. First, you will need to use the constructor scene from 3 to create a new scene. Then you will do the similar thing for the camera by using the perspective camera constructor. Then you will need to create a WebGL renderer and pass the DOM element as the canvas. Last but not least, you will need to tell that renderer to render the scene and the camera. So far, so good, right? Now let's talk about the way we are doing it in TresJS. Basically, we add the canvas component as a wrapper. Then we add the Tres perspective camera or the Tres orthographic camera. And alongside, we add the scene, because both of them are the ones necessary to render each time. All the objects will live inside of that Tres scene component. So TresJS is doing all the magic inside that you don't need to add elements into the render. It will do it for you. So let's try adding one object. The way you will do it in plain 3DS will be you create a geometry. So it's important here. The geometry is like the structure or the mesh, right? Like not the mesh, but like the structure, all the vertices, where are they located in the 3D space. And then you have the material, which is like how is covered, okay, and how it reacts to light, if it has reflection, if it has textures, and you combine both into something called a mesh, which is the final instance of your object. So here we are creating a donut by using the torus geometry. We're passing some arguments, and this is really important for continuing. We're passing, for example, the radius, internal radius, how many segments it has. Then we create the material. In this case, we are using the basic material, and we are adding a color. Then, I don't know why it's moving. It's so annoying. We are creating the mesh component by using the donut, and we are passing the geometry and the material. And finally, we are adding to the scene, okay? So how we do it with TresJS? Basically, we create a Tres mesh component, and you can already notice that all of the components are based on those constructors that you saw before. So inside of this Tres mesh, we are going to pass a torus geometry, and we're going to pass the same arguments of the constructor via a property called args in a way of an array. Same thing for the Tres basic material, but in this case, instead of passing it as an argument, we're passing it as a property or as an attribute, right? So yeah, the first time you see this is like, say, like, what? Is this gonna actually work? So the way it works is that we take the latest version of tree, so it's always up to date, and that tree object contains all those constructors that we were using it before, like tree scene, tree mesh, etc. Then we have something called the instant creator, which is basically magic, because it converts all of those into Vue components. We were talking about arguments before because they are really important. Whenever you want to initialize some instance in TresJS, you need to pass the arguments as a property, which is an array. In this case, for the perspective camera, we are passing the field of view, the aspect ratio, and some other attributes that are necessary. This is exactly the same as doing this in plain TresJS. We created it with the camera. And we need to add it to the scene. You don't need to add anything to the scene. It's already done by the library. Then you have props. In this case, you can the Tres perspective camera can be created without arguments, and you can pass those as properties, and it will be exactly the same as doing this in plain JavaScript. You will access the properties and set everything up. Then we have a really important concept from Vue.js that we use a lot here in the library, which are called Vue slots. So Vue slots are a way to pass other components inside of the wrapper and, well, basically render them. But in our case, it's creating a mesh. So the way we're using it is that we're passing the geometry and the material component as slots to the mesh component, and it will automatically create the following code. So it will take the geometry, the material, it will create a new mesh, it will add those as parameters, and then it will add it to the scene. Why is this so cool? Because it allows us to reuse code. So one of the issues normally when you're using plain TresJS is how you organize your code or how you can reuse code. So you normally follow up doing classes. In this case, we can create Vue components that has all the logic inside and then basically imported it into a parent component. In this case, we created a donut that is orange. We could even create some props to change the color and add it here, passing as a property. Essentially, whatever you will use with normal Vue, you can do it here. So until now, we managed to render something. We managed to render this really fancy orange donut, right? So theoretically, we actually achieved two of the challenges that we have at the beginning. Like it was keeping up to date with TresJS, and also something that is verbose and easy to use. You can get the documentation from TresJS, and you will already know what component you will need to use by only prefixing tres in the beginning. Now, let's try something more complex. We have a scene here that has a cube that is rotating in 2 axes, right? And it's doing like a fancy rotation. Also, this cube has like a reflective material that has different colors. So until now, we have rendered only one frame, like one image. You can see that this is dead. It doesn't do anything if I click on it, okay? So our idea will be to create something that is alive. Here we have the component that we will use for this cube is a tres mesh with a box geometry, with the width, height, and depth, and then a normal material that is used from TresJS. So how do we animate it? And this is one of the topics that are more fascinated of, because it's the same concept as in game development, okay? When we're doing like web, we normally don't create a loop because everything works in a different way. But in gaming and in 3D, we need to render every frame per second. If you're familiar with the content creation or maybe with gaming, you already have heard about frames per second. It's basically how many frames or images you can fit in 1 second to show an animation. The more frames you add, the more likely to be smooth. Okay, so in your case, if we want to modify any of the properties of our objects, we will need to loop over every frame per second, so every time the browser refresh, and then change the property that we want to animate. In this case, we are getting the cube, and we can add .position, .x, and change it every time. Under the hood, we can use request animation frame and pass the loop, so it's done every frame per second. Also important, after we change the property, we need to tell the render, please render again. But the cool thing is that TresJS does everything for you, so you don't need to worry about that. It's done by default. What you need to do to animate an object, and this is where things get interesting. I don't know if you're familiar with template ref, but we are going to use them a lot here in TresJS. It's the way that we can get the 3JS instance to make it to animate. So I'm using shallow ref because for performance reasons, if we add reactivity to those and we modify them, it could give you a little bit of performance issues, right? So if you use shallow, you will be perfectly fine with the frame rate. You will not have any drops. So we create a reference for our tres instance, and then we use onLoop. So this is when we're starting to use composables and the magic of Vue 3, because the use render loop, it has under the hood and takes for adding this as a contributor. He's from the Vue use. So he added some really nice Vue use composables inside that allows you to have every frame per second trigger a function back. So you have available onLoop. And this is a function that has a callback. Oh my God, this is moving too much. That will call every frame per second, right? So we take the reference .value of the box, and then we modify the rotation, and we modify the Y and Z rotation by using some of the parameters that come by default. Delta is using the 3JS clock under the hood. So it will tell you how much time between each frame has been passed. And elapsed is the time that has passed since the beginning. So you can use both for animation. Then we have something really fancy. Here I have like a model, okay? It's Aku Aku from Crash Bandicoot, one of my favorite kid game. And it's basically a camera controller that allows you to orbit around the target. It's really important to be able to debug your scene, okay, and go for it and check, okay, the light is correct and so on. So the problem is that this orbit control is not part of the core of 3JS. So then we have an issue because we are taking everything, we're creating a catalog from 3JS directly, and this is not in the core package. It's actually in a sub folder called examples, GSM controls, and orbit controls in the actual package. So how can we deal with that? The first time I saw like, okay, how we do it? So there's the first way. Fortunately, TresJS provides a way of extending the initial catalog of component. So you can do it by using the extend method from the use catalog. So you import it from the core package, then you get the constructor that you want to use, in this case, the orbit control, and then you use extend to extend the catalog. And the way of using in the template will be as like equally to any other constructor. You will prefix it with the tres. In this case, for the tres orbit control, we need to pass the camera and the render, but we're doing everything in the template. How we can get those instances to work with it? That's where another composable comes really handy, is the use tres composable. This composable will give you, it's like a state management. It will give you the camera and the render of your current scene. You only need to import it from the core package, and then you will use it like this. Okay, you can pass it directly to the template. There is a second way though, but we will need to wait a little bit forward the presentation to see this one, because it's gonna be awesome. Next on the list here are materials. So we are gonna start to look at some fancy demos. In this case, material, as I said before, is everything that shows the visual properties of your object, the color, how reflective it is, and so on. So here we can change the color to a different color, maybe a color that is similar to the branding of WeAreDevelopers, and then we can see, if we use the mesh, we can see how the geometry is formed. We can also change the type of material. Now it's like a toonish, like a Breath of the Wild kind of thing, but we can use we can use more like physically accurate ones, like the physical material, where we can change the metalness of it, how metallic it is, and how rough it is. So imagine that we want to do like a really plastic material, we will have less metalness, but if we want to do like a metal sphere, we will use in this one. So you see how awesome it looks with zero effort. Then we have textures. Textures are really mind-blowing for me, because it's really costly to deform geometry and create all those vertices. So there is a hack that, oh, sorry, Amazon. There is a hack that you can use 3D textures as images that contain multiple layers of data. So one layer of data will be the color. In this case, I don't know if it's visible, but like leaves, okay? And then you have one for the displacement, which is in black and white, and it will tell the mesh how much it can deform itself. TresJS provides a way of loading all these textures by using this composable right here, which is use texture. In this case, you will only need to pass all the path where you have your images in with the correct naming convention, and you're ready to go. Take a look that here we're using await. So whenever you're using this composable, remember to wrap in the wrapper with suspense. Here we have another example. We are taking the tres mesh, okay? Now in the template, we have the sphere, and we're using a standard material right here. We got all the textures in the PBR texture object, and then we can pass it one by one, if you want, as properties into the material, or even you can use vvine PB texture, and it will work right away. So here I have an example of textures, but only the first one is working. So bad. That's the beauty of live things. So let me see if I can show you here in the sphere. So you can notice that the sphere is not completely round, but actually the geometry is completely a sphere. This is done by the materials. So in previous gaming, like when we were playing like PlayStation 1 or Nintendo years ago, this was a really good technique to avoid creating too much difference in the geometry or too much vertices that could cause performance issues. So we were faking everything with the textures. Okay, since this is a really how do you say it, dense topic, and I will refresh it because I really wanted to show you this one. This is Ellie from The Last of Us. Maybe you're seeing the TV series right now. This is also done with TresJS, so you can add animation to your scene. It looks really scary, okay? But it was all for the sake of having a mental break. Now we can continue. One of the most important parts of any art in general, like photography, 3D, painting, is light. So André Deron, the co-founder of Fauvism, says that the substance of painting is light, and it's because it's fundamental to see the sense of perspective and depth into our scenes. It creates shadows and reflections. It makes them more alive. And basically, without light, we will not see any color. So as 3GS, in TresJS, we have a lot of different types of lighting. We have ambient light, which is like, imagine a light that is going in every direction and it's completely normalized. Then we have a directional light that is the same concept as the ambient light, but going in a certain direction. It's like a vector. So whenever you want to point into an object, or like it was a lighting in your studio, it will be like that. Then you have a point light. Point light, imagine like the sun. Okay, it's a bulb that is somewhere and is emanating in several directions and not in one. Then you have more fancy ones like the spotlight, which has this like circular kind of diffusion. And then last but not least, you have the cat lights that you can see at night. So everyone that have a cat knows what I'm telling about. How we can use them in TresJS. So basically, you will add a component with ambient light in this case, and you can pass the color and intensity as arguments. For the directional lights, there are more fancy stuff because we can pass the same arguments, and also we can use template ref for using a helper. So helpers are the way to visually debug our lights. So whenever this is load, or the template ref is load, we add the directional light helper with the following arguments. Oh, okay. I was going to show the demo for the lighting, but it seems like I messed up something. So sorry about that. Regarding this image right here. So if you take a look, this right here, and that's what I wanted to show you in the previous slide. This is the helper, okay? So the helper is showing where the directional light is going towards the objects. But you can already see that something's wrong, okay? That something is not realistic. So can you tell me what it is? I'm not seeing the chat, so don't wait for me to read it, but this basically, we are missing a shadow. So another cool guy called Leonardo da Vinci, that was a famous Vue.js developer, once said that shadow is the mean by which bodies display their form. So without the shadows, we will not actually realize what's the form of an object. Important to say, in 3D in general and in WebGL, light and shadow algorithms to calculate them are the most performance heavy of all. So be mindful whenever you're adding lights and shadows, especially if you are animating. That's why we need to actually tell to the renderer to start rendering shadows. We can do that by passing a prop to the Tres Canvas component called shadows, and that will enable them in the render. Then we will need to tell the light to be able to cast a shadow. We can pass it as a property called cast shadow. But if we look at our to our scene, we will see that it's not actually casting the shadow. That's because we need to tell the object as well to cast the shadow. I know it's a little bit complex and it looks really manual, but it's important that you select which objects you want to trigger shadows. So we pass the cast shadow to our sphere. And then you also need to tell which objects will receive shadows. In this case, we have a plane, okay, that is serving as a floor, and we are telling it, please receive the shadow. So now when we render again, we will see that the sphere is rendering a shadow on the plane. So I have another, that's really bad. I have another example. So let me see if I can go directly to the playground and show you there. Because I wanted to show you the lights and the material textures. Okay, they're no longer there. I'm sorry. Let's continue. So environment tweaks. There is a way of passing some properties to the Tres canvas as we pass the shadows right here. And the way of doing it is with these properties, such as passing the color, passing the physically correct lights. That means that more realistic renders, that is not that cartoonish, and other properties that you can see on the documentation of TresJS. So since I'm already seeing that most of my live examples are down, I'm going to do another thing, and give me a second. I'm going to basically run it on my local. Okay. So and our dev, give me a second. I'm starting it, and let's see if I can show you the examples. Everything that can go wrong in a presentation will be wrong. So, okay, let's share this table instead. Okay, so I wanted to show you like the animations and how you can change the color right here, for example. So you will be able to change different aspects of your scenes by using this UI right here. So that was the one that I wanted to share. Then you have events, and events are emit pointers, okay? So basically TresJS under the hood has something called the raycaster. So the raycaster will allow you to add events into the canvas. So whenever you click a cube or you point over like hovering, it will trigger a view event that you can also see in the Vue Dev tools. Here I have another model. Like the previous one are really good when you're showing like small geometries or you're doing basic
Alvaro,
demos.
sorry, very quick. We lost your screen. We can't see your screen anymore.
Oh, don't tell me that. Maybe I'm nervous. Give me a second.
I think it just disconnected or for some reason stopped sharing.
Yeah. What about now?
Yeah.
Is it good? Okay. So sorry about that. As I was saying, when you want to create more like detailed scenes, you probably need to import models from any software. So you have Blender, you have 3D software to create those models, and then you will like to import them into your scene. So for now, TresJS supports .gltf and .glb files, and also .fbx, which are the most common ones. But we are planning to add more formats in the future. So like how we could do it right now. We can use, there are 3 ways that we can load them. We can use the use loader composable. We can use the use GLTF composable from Cientos. We can use the GLTF model as well from Cientos. But like, wait, what is Cientos? So Cientos is another package, or it's like a sub-package of the ecosystem. And it's basically the Spanish word from hundreds, pronounced cientos. It's a collection of useful, ready-to-go abstraction and component composables that are not part of the core package, but to keep it like really small and simple, but you can do a lot more stuff with them. So the way you can install it is by using npm install at TresJS/cientos. So you got it, right? It's 300. After that horrible joke, I'm sorry about that. But what I wanted to say with this is that Cientos package is meant to be for the community. So the community can collaborate and contribute to this package and add all the abstractions, for example, for text in 3D, use animations composable, orbit control, transform controls to be able to transform, like I think I will show you the demo afterwards. Some of the loaders for the models like use GLTF model, use FBX models, and some shapes like the plane. And you remember that in some of the demos, there was like a box, a UI interface that I was tweaking some stuff. You can use this composable for doing that. So if you remember correctly, from where we were talking about the 2 ways of adding the orbit controls, I told you about the second one. And it's basically importing it from TresJS Cientos. So it's a ready-to-go abstraction of the orbit controls that you don't need to pass the camera of the renderer whatsoever. So it's really fancy. You start doing a little bit of developer experience right there and just using the components right away without worrying too much passing stuff. Another great example, if we were creating plane as a floor, right? So the way we were doing this with a mesh, and the problem with the mesh of a plane is that you need to rotate it 180 degrees, which is this part right here. So in TresJS Cientos, you will have a plane component that is already in the correct axis, and you only need to pass the material. Perfect. So we were talking about models, right? The first way of doing it is with a composable use loader. So with this, you can, it's similar as the extend functionality. You are grabbing the GLTF loader from the path here of 3JS, which is an examples and so on. And this composable will allow you to use any of the loaders that 3JS gives you. So if there is any of them that is not already implemented in Cientos, you can use it with this. The way of doing it is you will pass the loader as the first parameter and then the path for the model in the second one. Then you will get an object with the scene, and it's as easy as passing it with vbind to the trace mesh component. Now is when it becomes fancy, because in Cientos you can use the use GLTF composable that is a basic wrapper on the previous one, and it allows you to load right away .gltf and .glb format. You only need to pass the parameter here and also the options. In this case, GLTF allows Draco compression, so if you put 3, it will be already done for you. As the same way as before, you will get an object that is the scene, and you can use vbind scene on the trace mesh component to render. Then we have a wrapper on top of that, that is the GLTF component. So instead of using the composable, you can use a component right away that will pass as parameters the path and the options. And you can get the template reference via a template ref. This is really important because some of the time when you are getting a model, you will need to transverse it. Okay, this is a function that is available on the models to be able to go to each one of the children and change their properties. For example, if you want them to cast and receive shadow, you will do it like this. So we can watch the template ref right here, which is a shadow ref, and then we can use the getModel method to get the model instant from TresJS and then do whatever they want with it. As I mentioned before, there is a really cool one that allows you to debug your instance, which is use TwigPaint. So TwigPaint is a library that gives you this nice interface right here that has a monitor for the frames per second, which is really important for debugging. And also you can use it as a composable. It will give you one instance of the paint and you can use it as you will use the TwigPaint normal. Okay, so we're already finishing. I know it's a really dense topic, but I really want to highlight this part right here, which is that TresJS is meant to be an ecosystem. What does it mean? We have the core package that gives the raw 3JS experience, and then we're planning to have several other packages. So you don't need to install them all if they are not necessary. One is Cientos. Another one is performance, so to be able to measure the performance like really professionally, all the triangles that are rendered, etc. Then the post-processing, which is a really cool way of adding effects with Effect Composer. And who knows, maybe one of your plugins will be available on the TresJS ecosystem. Of course, not everything is perfect, and we have some caveats right now. One is the hot model replacement. So TresJS use Vite under the hood, but we are struggling right now to how to correctly dispose all the scene. Yeah, my cat is also helping me. How to dispose the scenes and the object when you're using hot model replacement. So more likely in this state of development, you will need to refresh the browser because you're going to get double lights, double objects, and things like that. We're working on it. If anyone here in the audience is really good with a hot model replacement, please give us a hand because we have been struggling a lot. And the other thing is that we need to be mindful about reactivity. Like Vue reactivity is not done for this kind of like loop system or loop approach. So it's slower than using plain objects. So whenever we are inside of the loop, be mindful about the objects that you have inside. If they're reactive, they're probably going to reduce your performance. So use shallow ref as much as you can. And if you're modifying something, don't do it by props. Don't modify the properties. Modify the reference that you're getting from the instance. If you have any more, I know this part is a little bit difficult. If you have any question, please send me a DM. I started like last year in December, but we have a little bit of a roadmap for this year. Today is the go live officially. So we're pretty happy to do it with WeAreDevelopers. And then we are going to work on unit testing, the hot model replacement disposal, a better state management, and try to automate the repository CI/CD for the first quarter. Also work a little bit on the plugin API for the community to be able to create their own plugins. And then, if lucky, eventually in the QA one, go public. So that means that the repository is going to be public and open source. Then we're already working on Cientos shapes. We have some contributors that already done it. We're going to do a Nuxt module to import Tres in Nuxt. And another way of using it that is a provider. Then we're going to work on the post-processing, the performance, and some material like reflective materials and shaders. Some resources, you can find the documentation in the link here. I'm also going to share in my social media the link for this presentation. You will have the Play3S Playground, which is Astro, actually. This is the one that I wanted to show you before. Okay, there are several demos right there. We have a StackBlit collection where you can find a lot of examples that you can plug in and play. We have a Discord community where we are sharing updates. Right now it's private, so if you want to join, send me a DM. And soon I will be giving a lot of content on my YouTube channel. Before finishing, I don't know how I'm with time, but I wanted to say thanks to all the contributors that make this possible, from Wed, Konstantin, Okoro, Jaime Torrealba, Adrian Stanosik, and who knows, probably in the future yourself. So if you want to contribute to the project, let me know to any of us, send a DM or just chat in Twitter, and we will add you to the repo while it's private. The best way you can support us is sharing it. If you like the 3D and Vue and you want to do stuff with it, share the project with your colleagues, share your demos, showcase them, send it to us or using these tags right here, and we will be more than happy to share them in social media. Also, in open source, it's always nice if you can give us a coffee or a beer by using GitHub sponsors. And by the way, you should have a GitHub sponsor button right here. I don't know why you don't have it already. My name is Álvaro Saurido. I'm a Storyblog ambassador. Originally from Barcelona, Spain, but I'm originally from Venezuela, but I live in Barcelona, Spain. I often write in Dev.to. I create a lot of content on my YouTube channel, Álvaro Del Labs. I have my portfolio in alvarosaurido.dev. You can always say hi in Twitter by using @AlvaroSabu, or in Mastodon if you're more fancy for the Elk and Mastodon client. That was about it. Thank you very much. I'm really happy that my first conference talk was today with you. And I hope you can appreciate also this gift from one of the best series about tech. Thank you.
All right. Thank you, Alvaro, for your talk. And thanks for announcing your library with us. We are very thrilled to have you here and to hear about it. It's been certainly fascinating. It's also nice to see that you are How I Met Your Mother fan. So
always.
Yes. So we have little time and many questions. So let's try to get through them a little bit quick. If not, we have to overdraw time a little bit, but I think it's okay. All right. We have a question. Can you import all the Tres components directly without using it as a plugin? And the main question is everything tree shakeable.
So yeah, one of the things that we were discussing at the beginning is that it needs to be tree shakeable. So in the roadmap, I show like a provider. The idea of having the provider is more like a React context. So it will replace the plugin, and you will have like a wrapper component that will provide everything by using provide inject. So all the Vue instances will be already available. So all the Vue components, you can use them right away, but they will be able to be tree shakeable.
Awesome. Next question. Is there an example on how to use TresJS with Vue 3 script setup approach?
Yes. Let me share the screen actually, because I have it right here. Sorry about the demos. I was really excited to show you the demos, but something happened in production. So you can see the StackBlit right now?
Yes, there we go.
Okay, cool. So in this example, I'm using setup like syntax with TypeScript, and you basically all the things that you need to import from CentOS or from the core package to create your scene will be in the script. Okay, you can create your this is way more complex. It's a shader material for the fancy thing right here, but then you can add the components here on the template directly. This is the portal right here. And if you go to the experience, you will see there is also a script setup, okay? And you're importing the component that is inside here, the portal and the Fireflies. and then in the template, basically showing like this. So it's basically like you will do any project in Vue, but with 3D. I don't know if that solves the question though. If not, let me know.
Yeah, I think it should answer the question. All right, next question. Okay, this is half joke. How does it feel to create a markup language by accident?
Well, actually, I think we'll probably do a custom rendering eventually, because I think it's the best way of doing it. I probably will need to try to talk with Evan in Amsterdam to see if it's something that we can do to have a reconciliation layer between custom renderers. I feel scared because I hope it's verbose enough and it doesn't complicate things. That makes them easier.
All right. How to use how to use three JS helpers, for example, directional light helper and the corresponding directional light.
Okay, let me share again because I have one tab with it. Let me go back. About lights right here. So the way you're doing it, like if you're using 3JS, you had to create two different constructions. So one is the directional light by using dot directional light, okay? And then you have the helper one. This helper is another object completely. You pass as an argument the reference from the first one, and this is the size of it, like how much it will take in the scene. Since if you want to do it with the templates, like the Vue component without doing anything in the script, you can use the template ref to get the reference here and pass it as an argument to the second. The only thing is that you will need to use a if to render this component because it can only render when you have the original directional light.
Okay. Nice. I hope that answers.
I think I do have an example on StackBlitz, but if not, let me know and we'll create one. I think it's an important topic to show.
Okay, nice. I hope that answered things for Toby. Is TresJS compatible with Nuxt 3? I suppose with the module you're planning, it will be.
Yeah, it's completely compatible. We want to have a better developer experience, more like also typing support like in IDE. And our idea will be that it's a Nuxt module that you can plug and play and you already have everything to work with it. And so that's important about Nuxt because Nuxt has this rendering SSG, and we are talking about Canvas, we are talking about the DOM, right? So this module will help to drive you to render them only in the client and not in the server. It doesn't make it's possible to do it in the server, but it doesn't make sense because you will duplicate work. You will do it also in the browser. So
okay, makes sense. Okay, you mentioned the use catalog. Okay, you mentioned use catalog composable, but didn't show your code. How would you use it? Or do you have a demo for that?
I didn't show the code. Yeah, I do have. I have demos for almost everything. Let me share again the screen. So yeah, here. To extend it, right? The catalog.
How to use the use catalog?
Right now, I don't remember exactly where is it. You will use it as any composable. So you will call the object from like const extend. It's going to be a function, and then you equal to use catalog. Okay, that will give you the method to extend the state, and then you pass whatever constructor you will need. You can also create your own construction, like create your own class and pass it there, and it will extend and will create for you that Vue component with your constructor. If I found it, I will share it on the. Please send me a DM in Twitter, and I will share it because I don't remember where is it.
Okay. Yeah. What else do we have here? Is it possible to have a custom-made shader in TresJS?
I love that question. Because it's when things start to get cool with shaders. Shaders is like more raw, like if you were writing in assembler in the computer, it's like really raw WebGL, right? So for example, the portal, the animation that it has like noise and so on, that's a shader. And you can basically import your shaders with .gls and pass it directly to the basic material component. And it will work right away. I don't know about time, but let's see. One last thing here I can show it. In the portal, I import the vertex and the fragment, and then you can pass it to the material. So since we are using like a model material, I needed to add it afterwards. So you create a new shader material. But this could be as well a component, a Tres component, and you pass the uniforms, the vertex shader as props, and it will work.
Okay, nice. So yeah, I think we can't answer all the other questions that we have, but just reach out to Alvaro on Twitter or on Mastodon, and he can answer the rest of you. So far, thank you, Alvaro, for this introduction to TresJS. It's certainly interesting to see how far you've come so far. Just very quick question: for how long have you been working on this?
We started in December. It was like 1 month, and now in January I have like 2 weeks that I could actually do things. But I was more focused on actually presenting this, creating the demos, and so on. But then I plan in February to try to work a little bit more on the hot model replacement and continue. So we do need help. So anyone that is interested to contribute, please let me know.
Okay, well, certainly congratulations to this. And yes, I will see you around. Thank you, Alvaro.
See you in Amsterdam. Ciao, ciao.
See you in Amsterdam. Bye-bye. All right, so before we continue with our last talk about petite-vue, we are going to take a short break and we will be back in just a few minutes. See you there. All right, welcome back. I hope you had time enough to sort of get water, and this is the last talk. After that, we will let you go back to your day. But this is the last talk of today, but last but certainly not least, Alexander Lichter. He is the founder of his own consultancy, web consultancy firm, and he's a contributor to Nuxt.js. Welcome, Alex.
Hey, everybody.
Hey, how are you doing?
I'm great. I saw lots of amazing talks today already, and I'm very happy to be here. Thanks for having me, and I'm glad to finish up this great round.
Yes, certainly. We are happy to have you here. I think, what are you going to talk about today? About petite-vue, but what can we expect from your talk? What will we learn?
Well, first of all, I'm pretty sure that most of the people who are listening right now have not heard of it. So for these people, like, oh, there is like a small version of Vue. Let's see what that is. And I will talk a bit about progressive enhancement, which is also like from seeing the whole topic of web development from a little different angle. from like, okay, we have like maybe a legacy application, just like a normal application written in PHP or Python or whatever, and want to sprinkle a little bit of reactivity on top, and to see how we do that without loading tons of JavaScript.
Okay, sounds nice, and I won't hold you any longer from it. Take it away, Alex. Good luck.
Thanks. So yeah, my topic, as Marc already said, is petite-vue, progressively enhancing every application. I don't need to do a big round of introduction actually, because there was almost everything said. I'm doing web development consultancy mainly with a focus on Vue and Nuxt. I'm a speaker and instructor, so giving workshops and also speaking at conferences, as you can see. I am also a team member of Nuxt.js. So contributing there. If you have any questions regarding that, feel free to shoot me a message. And usually I also talk about the topics, but today it's as I said, it's a little bit different angle this time. And of course I have a Twitter handle, I have a website, and I also have a GitHub account. So feel free to check that out if you're interested. And well, when we use Vue, all of you, we usually develop single page applications, right? This is the classic use case that's always like in discussion. Oh, we want to build a new front end, we want to build an SPA. Awesome. But let's start with a question here. What percentage of all websites, let's say the most popular 7.9 million websites that were like checked there, are single page applications? What do you think? Please, like, I have the chat right in front of me. Tell like a number or a percentage, like, I don't know, 50%, 1%. Just write down a number. What you think, how many websites are actually single page applications? And okay, the first number is coming in 15%. Okay, interesting. Any other guesses? 20. Not bad, not bad. 99. Alvaro, oh well, I wish. Or maybe not 3. Okay, I tell you, nobody knows. We do not know the number for sure. We don't know how many SPAs actually exist out there. What we know is that roughly 12% of all websites use a modern JavaScript framework based on the Web Almanac 2022. So modern, I count not like handlebars maybe, but like Vue, Svelte, React, and so on. But does that mean all of these sites are SPAs? Nope, definitely not. Not all of these sites are single page applications. I mean, we love writing Vue.js applications, right? But maybe, as I said before, we don't have a green field necessarily. We maybe have like an application that exists and we want to pimp it up. And usually legacy projects, like actual legacy, not just like written a year ago, but some of these too, are no SPAs necessarily. So maybe they use the classic LAMP stack, or they're like traditional server rendered Java-based monoliths, who knows? And yeah, that can easily happen. So of course, what can we do? We can say, yeah, just take that and rewrite it. But if the project grew bigger and bigger, it's not that easy. So often decisions are made against migrating to an SPA because, well, first of all, not enough time, the budget is too low, there is way too much domain knowledge in the code itself. Maybe the people who wrote that are not working at the company anymore, who knows? And also there is maybe not enough experience in like writing SPAs or working with the modern frameworks, which is also very common. And I experience that very often in my job. But still, if we have these kind of applications, they still need some kind of interactivity, right? We don't want them to be like static websites. We want to have some kind of modern approach there. But also often they say like, look, we want to be accessible. We want to work with no JavaScript as well. Because ideally that's what the web should be like, right? That every application is also accessible on assistive devices and whatnot. But then there's the question, okay, how do we do that? How do we actually ensure that this is possible? And there's a technique called progressive enhancement. So progressive enhancement is very common, especially if your whole front is not based on a JavaScript application. But even with these, you can do that in theory. The goal is to deliver essential functionalities and content to as many users as possible. Also, these that have this like JavaScript disabled are not available, obviously. And if you have an already server rendered application, like for example, as I said, with PHP, Java, Python, whatever, that's ideal. Like then you can just put some reactivity on top and still deliver all the functionalities that can be realized without it. So how do we do that? And now, very common, I myself, like long time ago, came from also the Laravel and PHP ecosystem and already did some Java quite some time ago. And in there, like for a long time in the like Laravel ecosystem, for example, I was like, yeah, okay, look, we just slap Vue on the application right away. We just load that and it's all good. And first of all, well, there's not much wrong with that. It works, but still you have a build step setup. So again, you have the layer of like, okay, you have your like backend application that renders also the content, but still you need to build your JS and you need to transform the single file components and you have code splitting and where do you load which code? Not that easy then. Of course, also we load 22.5 kilobytes. It's tree shakeable, but still need the right setup. And also the question is, maybe is Vue just too powerful if you already have content rendered to just like, I don't know, trigger a hamburger menu? Yeah, possibly. Depends on the use case. And also, are there maybe just too many new things to learn for developers that are not much into the JavaScript ecosystem and frameworks? So yeah, it's an option for sure, but is it the best? We'll see. Next we say, okay, but Vue is lightweight, right? We don't need a build step. Why can't we just use Vue directly through the CDN, right? That works. We don't have the build step anymore, but now we lose the tree shaking opportunity, and the bundle even got bigger because now we have to build the components during runtime because you can't just like combine and bundle them before and compile them. So yeah, also it's not possible to reuse the DOM necessarily. That means when the server gives you the DOM like to Vue, then yeah, it has to like throw it away kind of. With server-side rendering, for example, with Nuxt, it's obviously possible, but yeah, that's not ideal when we use Vue through CDN. That won't work. Also, as I mentioned, compiling templates at runtime with the runtime compiler is not only a bigger bundle, but also takes more time. And yeah, this does we throw away the existing DOM to some degree at least. And also the whole thing with the rule of least power applies here too, or if it's maybe too much to learn to new developers. So other options. Well, we can use vanilla JavaScript, right? We have no extra files to transfer. We can just ship the logic that we write. It's awesome. We only have the JavaScript files containing the logic. And it's great for tiny bits of interactivity. Like if I want to toggle a hamburger menu, great. But as soon as it gets more and more complex, it can be tough to maintain and also to reuse, and it's not really declarative. I mean, there is a reason why we have front-end frameworks like Vue. And often when I do like a JavaScript beginner workshop and then maybe transition to like a framework topic, then I usually show them this here, like, or give them a task, hey, build a simple to-do list based on JavaScript. And yeah, I mean, we have all in all like 50 lines for a very simple to-do list. And as I said, it's not really declarative. It looks messy. We transform HTML directly. Not ideal. Okay, so for tiny bits, it's great, but for bigger things, tough. So, okay, what else? Well, okay, one more try. Let's jQuery. No, don't do that. Really, don't. Please don't. There are modern ways and not jQuery. There is no reason for most of the things jQuery you can use plain JavaScript, and again, it's also not declarative, so better not. If you have the choice, well, there are some better alternatives. And one of them, well, you guessed it because of the talk title, I suppose, it's petite-vue. But what exactly is petite-vue actually? Well, petite-vue was released roughly 1.5 years ago. So on July 2nd, 2021. And it was created by this very, underground developer called Avenue, actually. Yeah. So that was also like a little side project of him. And we know how the side projects end up, right? Like Vue. And the idea is that it is a minimal subset of Vue.js, which is only a mere 5.5 kilobyte. The idea is here to keep it like Vue-like syntax and also to power it by the Vue Reactivity package, which can also be used standalone, as you might know. It has a little bit reduced feature scope, and very important difference here is it has no virtual DOM. So that means you cannot, like, it does not have its own DOM representation. It will just walk over the existing DOM, which also makes it a little bit faster if you use it only, for example, for specific areas of the page. Vue can that too, of course. Like you can say, oh, only mounted to this slider I want to make reactive, but not the rest. Only use it on this page, only use it there. So, okay, this is petite-vue, and let's see how we can migrate a little Vue single file component to petite-vue. So we have here a script setup code, right? Let's say our app.vue, and it's a very simple counter. And the first thing what you want to do is you take the template part and move the content of the template part into your HTML file. Then we need to apply a directive called vscope. And in there, we define the state or the data. In this case, we just say, okay, look here, great. We define the count that is 0 before the count was defined as ref over here. And yeah, then the only thing we need to do is we actually need to somehow load petite-vue. Because, well, obviously, we can also load it through CDN. And this also makes it very easy to use right away. So if we just plug out all of that together, it will look like this. So we have, again, a mere 8 lines. And if I copy this quickly and put that in the demo tab over here and put it in here, we have a working counter. And I'll zoom it in so you also see that it works fine in, not even 7 lines of code. If we ignore the import, it's way less. So, and the good thing, again, you can start right from the CDN, similar to Vue.js, but you don't have to do any crazy setup. Just import it, use vscope, and good to go. No diff, ID app, and so on and so on. So, important thing here, you might have noticed we gave the init attribute over here to petite-vue, to the import, which will say to petite-vue, hey, please just initialize right away. You don't have to do that, but in this case, well, we wanted to. And as I mentioned, we declared the state in the vscope directive over here. And the good thing is it will be available for all descended elements, right? For all nested elements. And another good thing is it's, as I said, it's very, Vue-like. So mustache syntax, interpolation works as usual. Event listeners works as usual because we have that add click here, right? That's great. So yeah, that's good to go. Also during the init, before I forget that, the idea is that the vscope directive will basically tell, okay, this is the element and all the nest elements that petite-vue should like make reactive. And of course, you can also do that like after the HTML is parsed, you can initialize it later too. So without auto initialization, it would look a little bit like this. Here we imported. We don't give the defer also not the init. And what we do is in another script tag, we just say petite-vue. That's the global name there. And then say create app and mount. That's the important part, to create the app and mount it manually. Also, what's very nice here, we can use the ESM build right away. So it's a bit longer, sorry. The modern build for all evergreen browsers, and can directly say we import create app here, which I will use for our talk now because it's the way to go. And okay, now let's say we don't want to make a whole application reactive and interactive, so let's just do it for a small part. And I have another example for you, of course. Here we go and say, look, okay, we only want to make a small part reactive, exactly the one that's with the vscope here, and we give that one an ID. And as you can see above, line line 17, we can just mount petite-vue to that ID, and then we make exactly these parts reactive. And the part above, the other parts, they are not reactive. That count will not be interpolated or doing anything. So it's all good. Also, the syntax with the mount might look familiar to you because it's very similar to Vue.js, to the classic Vue. We also have another cool thing, which is called a root scope. So when we call create app, we can just apply or just provide global data, so to say. So we can send state to this create app here. So when we call it, we can already pass in count and, as you can see, a method called increment. And the good part is that it will be available everywhere where petite-vue is in use. So yeah, this can be used as like a global function, so to say. And as you notice, that looks pretty familiar to the options API syntax. So yeah, you can pass data, but not in data, just like top level, and also methods that refer the data that you send in through this, like as you do in JavaScript, right? Easily. So also here, we add that increment method, and that will be used in line 5 by the button. And because we will just try it out right away again, we have our counter once again, and it works. As you saw before, because we call create app mount manually and don't use the init method, it will take a little bit when we, for example, reload the page. Then it will initialize, but that's also quite normal because it is working with the existing HTML and walking the DOM. So you might have that little flash, but you can also work around that with vcloak. Okay, another great feature of petite-vue is computer properties, because they don't exist. Surprise. But now you think, why not? Like, this is so essential in Vue.js. You can't live without them, right? This is the whole idea. And of course, this is not the whole truth. You can just use a getter function and things will work as expected, not accepted. So let's take that example and dissect it a little bit. We have our counter as before, and then we have the so-called digit sum. Here, in line 3, we just interpolate that data, and in line 12, we have a getter function, just like a get digit sum, and then return the string of the count. We split it up, and we sum it up with a little reduce. So yeah, that works fine. Again, we make sure that it really does. I count up. Okay, digit sum for like 1-digit numbers is really boring because it's the same. And now we come to 2-digit sum of 11 because 1 plus 1 is 2, and so on. So I will click a little bit more, and this works fine. If I put in count whatever, something like this in here, the digit sum is also calculated correctly. So computer properties work very well, but they're not called computer properties, so to say, because they're just getter function, and the Vue reactivity is dealing with it under the hood. Okay, what's another thing that could be really cool in petite-vue, because we have it in Vue.js too? Well, lifecycle hooks, of course, because, well, again, we maybe want to do something after the petite-vue has mounted or after something happened, and this is already a bit like boiled down because we don't have any VDOM and so on. And the examples here, of course, are very simple. And it should not be like replicating the whole Vue.js scope. So we have two hooks here, which are called addViewMounted and addViewUnmounted. And again, they can be used on each HTML element, and then we can say, okay, we do something or log something as soon as an element gets mounted or not, based on the VIF, because directives still work, right? So we can say, oh, if this is loaded, do something. If this is like destroyed, unmounted, do something else. We don't have support for like created, updated, whatnot. Created doesn't work because the HTML is not created by Vue. It's already there in the DOM. And updated doesn't work because, well, what should we update? There are no props or anything, right? So yeah, but again, they can be used for each HTML element, and we have this $EL shorthand to access the element that has been mounted or unmounted. And yeah, okay, we got that. We have computed, we have lifecycle hooks. Great. What else could we discuss? Yeah, right. Side effects. Because every app needs them, right? We need some way to trigger, like, I don't know, data fetching, random data, IO, whatnot. And to trigger them based on reactive values, we can use another directive called vEffect. So let's take this little example here. We have the vScope, and we don't pass any data here. That's fine. We have lots of data in our create app down here. And then we have a vEffect, and we say get data. And then this becomes really interesting. We will just like take it right away in the example playground here and make this a little bit bigger. And there we go. So whenever I put something in here, we use vModel over here in line 2, which also still works, right? Let's say I put on 1, then get data will be fired because the input is changing. This string is changing because obviously I'm changing it in the input field, and thanks to vModel, it will be updated. And then vEffect will say, oh, input get updated. Then we have to trigger this get data part. And then we say, okay, if this input does nothing, yeah, okay, we can return it. We can also just say this dot user is empty again, if we really want to. So that it will be reset. And whenever I change it, this will do another request with the fetch API to JSON placeholder API to then get the user, and I just show the username here. I can also show the full user object, but that's a little bit big. So yeah, it's okay actually. And that way we still have reactivity. So we have some kind of like reduced watchers. Also very helpful again to produce and use side effects. And now we might wonder, okay, it has quite some things that Vue has, right? But these examples, yeah, they're okay, but what is with like bigger applications maybe, or like bigger scenarios? Can we reuse code somehow? And the answer is, yeah, kind of. So let's talk about components in petite-vue. The good thing is petite-vue also provides a way to abstract components, even though we don't have like SFCs, you know? And in the end, components are written as functions that return the component state, getters, and method. So let's say we have this here. It's a function called numberList. And we give in a number on, oh, we have props here. Ooh. And then we say, okay, we get the smallest number, and we have another method this is called addNumber to add another number. And then we can say, okay, we provided component in our root scope, and we can use it. We can use it through vScope. So in here we say vScope, and then given the numbers, right? And we can do this again and again. So also here, let's put that in here and copy also, very important, the HTML, which I'll put a bit above. And let's see what is happening. There we go. So the HTML is also both the same, right? It's just different numbers. And the logic will also be exactly the same. And if I, of course, push data now, it will work as expected the minimum number is still 1. Well, that's a bit boring. Maybe we just do max here because obviously this is not a super good example, but now you might wonder, okay, I have to edit HTML again and again. We'll come to that in a bit. But yeah, that works separate from each other. Things work very well. And getting back to it, as I just mentioned, like, yeah, this is a bit annoying. What about the component templates? Can we somehow like deduplicate them too? And the answer is yes, we can. With the native template tag, because template is actually a native HTML tag. It's not something that like Vue came up. It's something that, of course, Vue used. So let's see. We had something like this here right away, right? We can reuse that by doing the following. We define a template. So in line 4 to 8 here, we say, okay, we have a template with an ID. We have numbers here, min, and the button, right? This works the same as over here. Same idea. And now in our actual divs over here in line 1 and 2, we don't provide any templates. We should just self-close them. And in our script, we can just say, okay, our component will get a $template key value pair. That's a reserved one for petite-vue, and just passing in the ID or the selector of the template. And that way, it will just work. So you can also reduce the template a little bit more. Okay, now you might wonder, great, awesome, but what can it not do? What can petite-vue not do? And the answer is, well, there is no render function because we don't have a VDOM. So on that level, we can't operate. But of course, you can use whatever DOM manipulations if you really want to in some lifecycle hooks. There is no things as like teleport, suspense, and any kind of other SPA features because it's not meant to build an SPA, right? Also, transitions are missing, but actually there is a plugin now. Shout out to the creator on GitHub with a few stars that works. It's called petite-vue transition. Don't forget the links in the slides if you're interested in that. And the slides are linked in the chat afterwards or on my GitHub. Also, we don't have any crazy script setup things. We don't have ref, we don't have computed, and we don't have any content security policy safe build, which is a bit sad, but there is a fork for that. So if you need that CSP safe, then there is a fork. And now, yeah, I already saw a comment in the chat. It's like, oh, petite-vue started to look more and more like Mithril.js. And when I was preparing the talk and was looking into it and was using it, I also had the feeling that there is like another framework that's very similar. Like maybe we should take a look at something called Alpine.js. And if you take a look, this is the code that uses petite-vue that we just saw. And this is the code over here that Alpine.js is using. And now you might wonder, what's going on there? So the thing is, there's a story behind it. Alpine.js is a lightweight JavaScript framework as well. Same use case. And it was inspired by Vue and even uses Vue's reactivity under the hood. So petite-vue, on the other hand, was inspired by Alpine.js to say like, hey, okay, we can have something similar, but more in the Vue ecosystem. And in the end, we already did a full circle. So, well, let's show the differences between these two. First of all, Alpine is 2 times larger than petite-vue and therefore comes with a few more features, to be fair, like the transition system. Also, the idea of Alpine is to go into its own ecosystem. And well, petite-vue was thought as just something more minimal compared to Alpine, but also like Vue compatible, because you see the syntax is very Vue-like and the migration to Vue would be very easy if that's needed at some point or if you prepare that. So that's a very big pro here. So if people say like, yeah, you know, I just want to get rid of this old framework there and maybe migrate to Vue at some point, I think that's a very valid strategy in some cases. And yeah, that's basically that. So when I would build web applications, just to round it up once again, my decision tree would usually be very simple. If you have a greenfield project, well, then I would personally say, go for Nuxt.js. Usually, again, it depends on the application, but there are very few where it's like, yeah, it doesn't fit. If there are only tiny pieces of interactivity needed, then yeah, just go for the vanilla JavaScript version. That's fine. If there is a modern framework, and I really emphasize modern here, already there, then usually there is no incentive to migrate. Again, modern. And if it needs advanced features and it's not a modern framework, well, then we can go for Vue.js if it's really more like app-like. But you still want to keep the like dated or like the traditional server rendered situation. And if it doesn't need, well, then we can go for petite-vue. And now we come to the part where I'll do a little bit of live coding. So I see I'm at 30 minutes roughly. So I will keep it very short. I have this blank canvas here and we'll do some cool stuff. So let's go first. Also very important, I loaded the Tailwind CSS CDN here, so we can use that right away. Yeah, they also have a CDN. And we start with some very simple things. So let's do some screen utilities to span it over the whole thing. We do little flexbox items in the justify center, and we give the scope right in here because we want to use petite-vue. Let's close the div, and let's maybe also import petite-vue right away. Script type module. I'm just thinking, yeah, we don't need to initialize it right away. We'll give some global state in. We import create app from. I really don't want to type that here. Okay, taken from the slides. Awesome. And now let's say we create an app, because obviously we want to do that. And we pass in, let's say, was clicked, and it's false because there's nothing to click yet. And on click to handle some things. So, well, we can just say this dot was clicked. It's true to change that. Or this dot was clicked is not this dot was clicked, but we'll just click it once. In the meantime, Fabian just said like, yeah, no IE11 compatibility, that's right, because it uses also Vue reactivity under the hood, which is proxy based. That's correct. That's also a very valid point. My condolences to everybody who still has to support IE11, but I know there's still some people out there. I understand that. Let's mount that application and let's just log was clicked, or out here, maybe let's, yeah, there we go. We have was clicked and it shows false. Awesome. There we go. Very, very simple. Let's create a button and say add click on click. And say click me to progress to the Q&A. There we go. And maybe I'll put a break here. How about that? Line break. And I click and it says true. That's cool. But sadly, this is not the end yet. What we also want to do is we give it a little bit of style. So, and remove that was clicked because that works now. That BR. So let's say we give it border 4, some padding, some bigger text, something like that. Oh yeah, that looks better. And now we want to create an image. We give a source and we take a placeholder image to not spoil the fun. Because again, there we go. We use vcloak here to ensure that there won't be any problems. So that we don't have, that we see the image after it's been loaded. That's very important. We also should probably apply the vcloak CSS style a little bit, because that's we should do here to say like vcloak display none, so that it will not be displayed when we reload the page and we don't spoil the fun. And now let's continue with what we want to do. We want to say vif was clicked. Right, then we want to show it. So that works very well. You want to hide the button when it was not, so when it was not click on a show, otherwise you want to hide. That works very well. And now we trigger a reload of the site. We also see during the reload, if it would be kindly reload. Thanks, that we don't see the image anymore, which is great. And now we give in a little surprise image on here. And I hope you are ready to click. So let's go for 3, 2, 1. There you go. You got rickrolled. And let's finish this up. Let's go almost to the Q&A. A short conclusion. Yeah, not all projects are SPAs, and actually also some don't even have to be. There's another tool in your tool belt, so please use that, right? If you only have one tool, then everything, I don't know, if you only have a hammer, everything looks like a nail, you know it. Petite-vue and progressive enhancement are a perfect match, and petite-vue is part of the ecosystem. It will be very easy to migrate to full view if necessary, and yeah, well, in the end, we're just saying we love writing Vue applications. So thanks a lot for your attention. I'm Alex, and also thanks a lot to my sponsors who sponsor me on GitHub. Shout out to everybody and to everybody who contributes to open source. So yeah, that's it. Thanks everybody. I can't hear you yet, I think. Maybe that's my bad.
Nope.
Ah,
Oh,
there we go. Good.
Again, I had like one job.
Well, you're doing great. Don't worry.
Thanks. So yeah, thanks for your talk. I heard about petite-vue just, I think, like on the side somewhere. I haven't really used it or looked into it. So this is a great primer to see what it is. Everyone in the audience, please send your questions in so I can hit Alex up with them. And yeah, I have one. My first question is though, I love your microphone quality. It's very studio quality. Which microphone are you using?
I just used the Rode NT1A, very basic. As an interface though, that I also play the funny sounds. I used the Go XLR, which is very nice. Also has like different channels for everything, and also a little bit VFX and all that. So yeah, little things to play around with.
Nice. That answers my second question. How do you play music with a GIF?
Yes. I was like,
Sneaky.
I was thinking, okay. I usually what I wanted to do is like playing sound, but I know that the sound is not transferred. So I was like, yeah, I don't want to like reroute it. I would just like play it right away, and then there we go.
Nice. Now I'm jealous of your audio setup.
Well, I hope I can use it more in the future for more content creation. I'm planning to do more this year. So
Oh,
yeah,
nice.
stay tuned.
Yeah, we will. All right. Oh, we have one question from Fabian. By the way, Fabian is asking a lot of questions. Thanks for that. It brings a lot of value to this show.
Absolutely.
Are there class binding shortcuts or similar?
vbind should also work. So I would say yes. The directives from Vue, they should almost all work. Like vshow, vf, vbind. So yeah.
Okay, nice. Any other questions? To be honest, I listened to your talk and I was like, yeah, this is pretty clear. I don't have any more questions.
That's
But-
even better. And
Yeah,
also, I
but-
think like it's a little bit of a niche topic because lots of people are like, oh yeah, SPAs all the way, which I totally understand. But especially because it's like a not so well-known project, I really like to introduce it's like, okay, this is also a way you don't have to like migrate every application going like full-blown Vue. So yeah.
Yeah,
as usual,
spin up a Nuxt project.
Well, I would almost nobody stop from that. But if it's like, oh, we have jQuery, let's replace that, then it really
Yeah,
depends on how the usage is and so on.
Yeah. I mean, if you use if you use jQuery, you have other problems.
Yeah, exactly.
A
But,
lot
I mean,
of
there's
spaghetti code.
Yeah. I
Problems.
still have a project running that I just don't touch anymore, except like just doing updates, and it still has lots of jQuery, and I'm like, no.
Just text changes. Are
Yeah,
fine.
exactly. Every year,
Yeah, okay.
the year of the copyright in the footer.
Awesome. All right, cool.
Good.
So, there are no more questions from the audience side. I have some questions that I like some general questions, like for example, what is some tech that you are most excited about in the next 5 years?
In the next 5 years, I don't know what will come up in the next 5 years. Man, like, who? Actually, one thing that I thought a little bit about it. In the background, somewhere there, there is a new little laptop I bought, and it was very interesting that they silent dropped the M2 MacBook Pros. So I'm like a bit curious what Apple will present at their main event, because some people like, yeah, they did it for like increasing the numbers, but they didn't like announce it like very like publicly. So it's like, maybe there's something really cool coming up. Other than that,
nice.
yeah, AI is a big topic now, but it's as with many things, we'll see where it goes. And I think I'm still very excited for the web. I mean, I'm like writing code since I'm 13, so like for more than half my life now. And the web is always very intriguing and fascinating, and I'm curious where it will go.
Yeah, me too. It's, you know how it is when you try to project like some future, like people like from the 60s projected like flying cars and stuff, and we still have combustion engine cars, like with diesel going around, and it's like, nah, it didn't turn out so great. So yeah,
maybe in 2050. Who knows?
Yeah, it doesn't even seem practical, like a floating car.
But like more like self-driving cars could be more interesting, especially for public transport and whatnot. And
yeah, but still a lot of work to be done there.
Oh, absolutely. Lots of research topics.
Yeah, lots of research, also a lot of legislation stuff.
Yeah, as well.
And like politic moves, and we are against Elon Musk, so we will deny all of these. Yeah, you know how it is. But yeah, do you have any cool hobbies we want to know about?
Any cool hobbies? Wait, Marc, you know one of my hobbies that I do not that often, but every now and then is somehow, especially at conferences, I like to play a round of chess.
Yeah, nice.
So I'm always up for that. If someone wants to play around, then also hit me up on Twitter. I'm not super good, but I understand the rules. I can play with, so I'm very happy to join.
Oh yeah, I understand the rules. And last time you won like 4 out of 5 when we played, and just because you didn't see like my trap.
Yeah, well, that's also part of like, you know, that's how it goes. But I hope we can play another round next week.
Yes, I see. This wasn't even planned or anything, but everyone that talked today is going to be there next week in Amsterdam, so we can all hang out as we are dev graduates.
Exactly. Though I won't give a talk, but I will stay on stage for a few minutes and announce some people and make maybe some bad jokes. Let's see.
Nice. I will give my very first talk there. At that venue. Is the first time I'm in front of that many. Well, I spoke also as a moderator there, but not as a speaker. So live coding in front of 1,500 people or 1,200 people.
It's lovely. It's lovely. You will really enjoy it. I can promise.
Awesome.
And yeah, maybe another thing that I feel also Jakub also mentioned, Jakub Andrzejewski on Twitter, that I also like to play in a run of Dungeons and Dragons, and of course you're also happily invited to join. I also saw your interest in that. So
yeah, I'm intrigued by it, especially after Stranger Things, right? But
yeah, exactly.
Everyone is like, and now there's a movie coming out, right?
Yeah, but I'm very curious about that. I heard some very polarizing opinions on that, but I will take a look for sure.
Okay, awesome. All right, so since there are no more questions, let me just check in the chat.
Yes, sure.
No. Just someone said it's a shame that it's not IE11 11 compatible.
Yeah. I mentioned it briefly. Like this is because of it's based on Vue Reactivity, and yeah, but again, condolences to everybody who still has to support i11 because I feel the pain.
Yeah. All right, then. Thanks, Alex, for your talk.
Thanks for having me.
Yes, pleasure too. And well, we will see each other next week, I suppose.
Exactly, right.
All right. Bye.
Bye.
All right. So I think we are done here, but I'm going to give the control back to Vienna to my colleague Bene. If he's there, come in, Bene. There we are.
Hey, Marc. Hello again.
Hey, did you
Thanks so
finish
much for
playing
taking
with
over.
your Oculus Quest?
Sadly, I didn't get the chance to use it, but you were doing such a great job moderating that I didn't want to interrupt you. So thanks again for that.
Awesome. Was a pleasure. Was a pleasure.
Yeah, it looks like you had fun.
I did.
Very happy to hear that. So thanks again, Marc, and we'll see each other soon.
Yeah, see you around, I suppose. Bye-bye.
Bye. All right, and now that this topic day also comes to an end, just a few more things. First, thanks and huge shout out to all of our partners who help us in making events like these possible. Check them out by scrolling down on the live page. The logos there are clickable. Just click through and leave them some love on their websites. Second, if you are interested in diving into the virtual reality world, we've partnered up with Deloitte and raffling out a MetaQuest 2 VR headset. While you're down at the live page, just click the button to join the raffle and get a spot there. Also, if you are interested in meeting maybe Marc and some of the other speakers of today and the other live events, go to worldcongress.dev to get further information about our World Congress, which will be in July in Berlin as an in-person event this year. And now, also check out our upcoming live days. For example, in 2 weeks' time is the DevOps Day on February 15. I hope to see a lot of you also there. Thanks for joining and see you soon. Bye.